Okay, it looks like we're live, so welcome back. Today I'm going to be continuing to build my fourth interpreter. Okay, so I haven't looked at it at all since last stream, and that was about 2 days ago, so it might take me a second to readjust. But this is what we've been working on. So FizzBuzz, we almost have it working. So if I run this right now, yeah, main.go, and I need to actually provide the file. Okay, yeah, it doesn't do anything. But if we call just fizz, it should, if I remember correctly, that should output fizz properly. And if we call buzz, it should not output anything unless it is a multiple of 5. So I think those two are working. Buzz. Okay, so the problem we found out was with the labels. So it is in here where it stops working entirely. So I think, yeah, that, okay. If I call something, which I should probably change the name of that, but yeah, it doesn't do anything. Well, actually, I called it wrong. We do need some errors, because we don't have any errors if we call a function that doesn't exist or anything like that. Okay, yeah, so that just outputs numbers, from 1 to 25. So that's not exactly what we want, because the reason it does that is because this function doesn't work, essentially. So yeah, we can actually debug that. FizzBuzz. Like that. So when we call that, it should do stuff. But it does not. So we can look in the main.go file. Main.go. Let's see. Let me actually swap these around. Okay. So, in here, whenever we enter a label, we should probably print what is going on there. So, let's see. Print line. And I want to just print the value. And we can sort of see what's going on here. Okay. So actually, I didn't mean to do that, but it actually does print it out with both properties that it has. So that is pretty nice. So this is the token essentially. So that is the value that it has. So it has all of these in here. And I don't think that's exactly what we want. Let me just print the val.value and take a look at it like that. Yeah, so this is just the value of it. So that's just the one left-hand side of it. So it shouldn't have all this stuff in it. Yeah. So, and let me do just fizz, and that should just have the stuff for that. And it doesn't. So, did I do that right? Let me see. So this outputs fizz. Yeah, so, yeah, it's all a bit messed up. Yeah, so if I put 5 in here, then it's going to output buzz as well. It does not. Okay. But it still has all the things in here. So this is a tad strange. Maybe I should print it just when we encounter a call to the word. So, where is that at? Inward, there we go. So in here somewhere, right here, perfect. I will just print the value once we encounter that, and we can see what it actually calls. So we just call fizz, and if we call FizzBuzz, it should just call FizzBuzz. Okay, so the calling is proper. But we don't actually see the calls in here, so I think it is not making them properly. Okay. Let's see. Currently equals that. Alright, yeah, so it still outputs that. So that is a bit strange. Okay. Alright, so up here actually, we encountered this. So it's a word type. Actually, is that the issue? Because we're not actually appending that. And word tokens and val. Let me just try that. Run that now. It still doesn't do anything. Okay. Yeah, so it still is working the same. But if I call fizz, does it work? Okay. That does work. And then shouldn't do anything for that, but it should be for buzz. Let's see. Okay, so those are still working. I feel like we do need to append these though, so I don't know what this check is about exactly. If I just get rid of this entirely. Yeah, actually remove that whole thing. Because then this will just be called. This one down here, at least. That one should be called. Then, yeah, then it loops forever. So, that is not particularly good. So why do we have to do this? I'm not sure. Ooh, it might be because of the I minus minus there, actually. But now it loops forever. Did I mess something up? Let's see. Because it's just working. But now it is not. What? Okay. So, now it doesn't work anymore. But, if I get rid of that, it does work. Huh. But it was just working a second ago with the same code. Alright, so why would it loop forever if we do that? So, is it not iterating? It should be iterating. Alright, so word tokens. So we append that. And we do want to do that. But why would that make it go forever? Whoops. I accidentally exited out. That is not what I wanted to do. Okay, so... I must not have saved it. Yeah, so that is why we have this empty here. But we do need to append that if we have a word type in it. Because that's why it doesn't actually call it when we call a function from within here. Or call a word, rather. So we need to append it, but not have it loop forever. So why does it loop? Whoops, I just messed up. Go run, may not go, test not full. And it loops forever, so... Oh, okay. Yeah. So I remember why now. So when we encounter this first one, it adds that as well, and then it tries to call it over and over again. So, we don't want to do that for the initial word. So, So in here, yeah, so when we encounter this, this is where it is being set, essentially, in the colon type. Yeah, but we want to iterate this so that we can kind of skip over this. So, can I just do ++ like that? Will that work? Let's see. Alright. So it doesn't want me to do ++ in there. So what if I just do I++ and then I call this? Okay. Alright, that looks pretty good actually. I call something. Then, oh shoot, I think it might be working. Let me actually get rid of that print statement that I have in here, these two. Because we don't want to call those. So, now if I run this, okay, so that is almost right. Yeah, so the printing of the numbers aren't exactly right. But it is pretty close. It is actually properly calling the functions. It might be a problem with the program. Did I actually write it wrong? So here is the FizzBuzz program. Let me rename it so that it actually matches. Do FizzBuzz, and then we call do FizzBuzz. Do FizzBuzz, like so. Now if I run that, okay, yeah, so it's still the same. Obviously that won't change anything. So we put 25 and 1, do, print a new line, I, okay, and we call FizzBuzz on the I. And then if I, then you loop. Okay, so if that is true, so are we not returning something properly from here? Alright, what is the value on the stack after we call fizz? So if we put 3 and then fizz, and then we return that, what do we get? We get 1, so that is true. And if it is a false value, well actually, -1, that's what it is. Then it's false, so that should be fine. So it should skip over this. If that is true, so I think, when we call this, it is not, the I might not be working properly. That could be it. So if I do, just make a test function here, and then I just, let's see, if I do a do, so just, 5 iterations, starts at 1, do, and then I would just print I, then, and just end that, and actually I need a loop. I don't need the then, I need loop, and then I'll just call foo, and let's see, 1, 2, 3, 4, okay, so that looks fine. Let me print I here, and call do, so this is gonna break it, but I want to call it. Okay, so we actually get some issues. Index out of range -1. Ooh, okay, because that doesn't exist. So let me actually do and then call it. So then it should. All right, let's see. So the iterations are right, but for some reason, it prints buzz on 1 and 2. So is buzz broken now? So if I push 2 and call buzz, is it broken? No. So it doesn't print. But it does when we call it up here. So that is a tad strange. Because this is what we're calling it on. That is the value on the stack. Ooh. I call is buzz. What does it output? Alright, it outputs buzz. So that is where the issue is. That is strange. Okay, so is fizz buzz written wrong? Alright, fizz, and then swap buzz. Okay, so so why does it print that? So when we dupe, what are we duping here? Let me print that out. Let me dupe again and then print it. And we get 2. So oh, but that's actually the wrong place. So I'm gonna call it on buzz. So swap and then dupe and print right there. 0. Okay, so when you call why is it 0? When you call 0 on there, swap might be broken. That could be it. If you call 0 on buzz, then it outputs it, right? Yeah, so that is the issue. So I need to figure out why that's 0. I don't think it's a problem with this, because it, in here, that is how it is set up. So, let me call fizz. And that outputs still. And then we have true on top there. So that is the issue with that. Okay, so, why does it become 0? Let's see. So let's just push 1, and then do, and then call fizz. So basically, do what this function is doing. And then swap, and then we'll print out when it is there. And just that is what we need, okay? So if I run that, we get 0. So it does become 0. So swap must be broken. What is on top here? 0 is on top. So, okay. So that must be where the issue lies. So when we call, let me look at swap. So how is swap implemented? Let's see. Down here, so we pop it, and then we push it off in reverse order. That could be fine. Hang on, let me call, let me do swap. So push 1, 2, swap, and then print, and it should print 1. It does. So, okay. But this brings 0. But what is on top there is 0, right? Yeah. So, do I need to drop the value of that? No, because we need that. What if I don't swap? What if I don't swap? What does it do then? Yeah, it's still 0. That should just swap it twice, so that should be the same output. Why is it 0? Okay, so there's 2 zeros when we swap. So are we duplicating something? So here, alright, let me push 3. And then I print fizz. Yeah, and then it just prints fizz. So it works when we do that. And we have 4. So, I don't understand where it's breaking exactly. So, we dupe this, and that should be 4 on top. So if I print it twice, it should print 4 twice. Then stuff breaks, but it should. Alright, yeah, it breaks when I do that. So let me do that, and then I'll do it on a new line, and I'll work through it one at a time. So 4 and 4, so that works. So we dupe it, and then we call it fizz, and then we'll print the output of that. It is 0. Let me get rid of this line. So we get 0 right there. Okay. And if we print it again, it should be, it's double 0. Okay, so that is, ooh, okay. So that is actually returning it twice. So that is an issue. Okay. 4, and then just call fizz, and then print it twice, and it's double 0. So, we can just drop here. I need to figure out why that's doing that. But if we just drop right there, then we should be able to call it. Let's see. Let's do 3 and fizz buzz. All that, and it should. Yeah, it does print it. And then if we do 4, it shouldn't print. Yeah, it prints the 4 because we're actually doing that here. So we don't want to do that. But now if we call it, do fizz buzz. Just call it like that. Okay. So it prints out the number twice. So it's because I have, is it because I have this? Yeah, I think so. Okay. So the new line doesn't quite work exactly. But that is just about right. 1, 2, 3 is fizz, and then 4, 5 is buzz, 6. Okay, so that is the issue. So it, for some reason, duplicates the value when I call this. So why is that? But buzz does not. So if I call 3 and then call buzz, and then print it out twice, it does duplicate it. So, let me drop that, and then call the do fizz buzz again. Okay, then it fixes the new line issue. So it works now, but it's not working. It's not right. So for some reason that outputs it twice. So let's see, is it something in the logic equals dupe if fizz? Okay, so if it does that, oh shoot, actually, is it because of the dupe in there? Because okay, hang on, let me do this. Yeah, okay. Let me do 3, 3 mod 0 equals, and then print it out, and we get -1, so that is true. Then if we dupe, and then if fizz, then, alright, don't need that. Okay, yeah, it doesn't let us do if statements in there, so I need to actually just make one. So I will just define it here. Fizz, there we go, and then, okay, and then call fizz, and we get fizz, but if I change this to 2, and then print it out again, print 0, and then it prints -1, why did it do that? Actually, hang on, let me do that. Okay, so this, it doesn't work, it doesn't do that in here, so it is definitely an issue with mine. But is the if supposed to pop? Is that what the deal is? So we have a number here, so 1, and then 3, then we call mod, and then there is 1 on the stack. Okay, so when I do it on mine, is there an issue with that? So let me do 1, 3 mod, call that, run this, and actually I want to print what the output is. We get 1, okay, and then if I do it again, there is nothing else, so it's not there. Let's try to figure out exactly what it is. So then 0 equal, print that out twice, like that. We do get that again, so if we print it out, then we get 0, because they're not equal. Okay. And then we duplicate it. So we have 0 and 0. But if doesn't pop. So if doesn't pop, is it supposed to pop? It's not supposed to, because it didn't before. But if we make it pop, it would work, right? It would work. Let me look at it. Yeah. If I make this pop, then it work, right? Right. Okay. Pop. And then I'll do fizz buzz and actually get rid of the drops in here. Then then it works. Okay. But if isn't supposed to pop. What? I am so confused, because I had this problem the other day, and that was the issue. It wasn't supposed to pop. So let me do a test here. So if I do 0, and then do if, and then print, then, and do that, and call foo. Okay, and dot. Also call foo. Alright, there's stack underflow. Okay, let me go back to this, and then make it 1. Call foo. And we get a stack underflow. So if is supposed to pop, what? But it didn't before. Oh my gosh. Okay. Let me go up here to the if statement. Hang on. I swear it did. Holy moly. Swear it did. So, let's see. If then. Alright. Buzz is 5 mod 0 equals. Yeah, look. It doesn't here. Yeah, okay. Then do that. And call buzz. Actually, we need to follow with a number, so we'll do 5. And actually print the number. There's a stack underflow. So it is popping. Let me make a new one. Alright, let's do foo. And then, let's see. Push 1. If. No, but we just tested that. Oh, man. Okay, so I guess it's supposed to pop. Sure. Sure, whatever you say. Where else did I need to pop? If type and else type. Do you want to pop on else? Yeah, probably. Probably. Okay, well, sure. Okay, well, it works now. That is what I wanted. It doesn't print the new line on the last fizz, but I don't think it's supposed to. If I, can I clear it? That doesn't work. Okay, let me just copy and paste this right here, and then I want to run this, and see, make sure the output is the same. Yeah, and then we can just call it do fizzbuzz, and it should be exactly the same. Okay, and I don't think there's a new line here. Yeah, there's not, or else the OK would be on a new line. Yeah. Okay, so it is working as expected. We can just call another new line here because we know. And there we go. That is fizzbuzz, and it works. So that is pretty cool. I can make this 100, and that's typically what you do in fizzbuzz. Actually needs to be 101. Because that is usually goes up to 100. 99, and then why is 100? Yeah, that is right, actually. Yeah, so that is good. So fizzbuzz, it works now. Works as expected. So now we can work through and do one of the other things. So let's see what else we have here. Variables. So that is probably the next thing. Okay, so fourth allows you to save variables in variables and constants. Okay. So is generally played by the stack. Variables in fourth are used more to store state that may be needed. So, alright, let's look at how it works. So, variable balance. And should be nothing, right? Balance. Alright, so actually, let me drop that. Push 1. Variable balance. Then it takes 1 as the balance? No. So, what is it doing? Particular memory location with the name balance. Okay. 1000 on the stack. Okay. So, that is the thing. Store the value. Alright, so this is, we're going to have to do memory stuff, so that is okay. The word that stores the value at the memory location. Alright, so if I call up here, if I call balance that, then just pops it off. Okay, so and let me see. I want to mess around and I want to make sure I do it right. So variable balance. Okay. And then call balance that, and then call this balance, and it pushes that. Okay, so that is how it works. So, alright, I think I see what it does. So, if I do variable balance like this, and then balance at, there's nothing, because there was nothing on the stack. But, if I push 5, and then do variable balance, and then call balance at, then there's still nothing. Okay. Balance at. Okay, so how does it work exactly? Oh, I need to actually do that. Okay, that is not right. There we go, like that. Like that. There we go. And now when I call it, then it is 5. Okay. So I think I see how it works. So that gets the top of the stack, the memory location. So if I actually drop that off, then it won't work, right? Drop again, and then call balance at, and it does still work. Okay, so it doesn't matter if it's on the stack or not, I suppose. Or what if I push like 10 on the stack? Then will it? It's still 5. Okay, so it keeps track of that. All right. Okay. The word. All right. So when we do balance, it basically just saves it with nothing, right? So yeah, let me drop all that off. So variable test. And then, yeah, we just do test. Then it is just the memory location of whatever. If we do test at, then it is just nothing. Okay, so it's initially 0. Okay, so we're going to need a variable hash map for that. Let me just get rid of all the fizzbuzz now, because we know it works. Yeah, so a hash map for variables. So I suppose I will want to pass it here. So, yeah. Let me do it after all this, because I think that'd be better. Okay, so let's just do variables is map. So yeah, we're gonna have a string, and then it'll just be an int, right? That is all it should be, I think, if I am not mistaken. So let's make it here. So variables is string to int. Let's see, is it just a single int, not a list of ints? Okay. And we can pass that in here, variables. Perfect. So we initialize the hash map. So now, basically, we need to lex this properly. So, yeah, let's just add variable type. So, I guess I'll just put that down here. Variable type. So that is the keyword variable. And then, yeah, and then after that, it'll just be a word, but we'll be able to just basically check the next token and we'll use that. So, down here, we'll do, yeah, if it is case of variable, like that, then token.category equals variable type. Perfect. So now we lex it. That's all we had to do. Then down here. Okay. No, I want to do it right here. So case variable type. Then, yeah. So basically, we want to do I++. And then do, yeah. So val equals tokens I, something like that. But first, yeah. So we want to actually put that in the hash map. So that is what we want to do. So we can just do variables. And then val.value. Yeah. Variables val.value. So yeah, then we just want to place that in the hash map. So how do we go about doing that again? Do we set that in here? Where do we words val.value? Yeah, so we actually set that up here. So we can look at how we do that. Yeah, so then we can just we'll initialize it with 0 initially. Or well, yeah, so we want it to be a pointer to the pointer to what? Really it's just a pointer to nothing, right? We'll just initialize it with 0. So that's the value. And then the value will change when you set it with word and then at. So yeah, I guess to check this, we'll just check if we have a word, and then if the next one is at or exclamation point, or bang, I guess, rather, then we will do the corresponding thing. Otherwise, we'll treat it like a regular word. Okay, so variables. So, yeah. Okay. So when we just call balance, we're just going to return the pointer to this value, right? So, I think we can do that. So if we have a word, word type. Okay. So let's just check here first. So if word, let's see, variables, word. So how do you check? Go check if key in map. That is what I want to know. How to check? Okay. Okay, so that's what we have to do. So, there we go. Error. Okay, so I guess it's okay. So it's like the opposite of an error. Equals variables and then val.value. Then if okay, then we'll do this. Else if we want to do treat it like this stuff. Else if that's so. This means we got it. So then we will just push to the top of the stack. So stack.push. Basically the value. Val is the alright, so then yeah, variable. Push variable. But we want to push the whoops, I completely messed that up. Variable. So I think we can just push the pointer to it like that. Then we do variable test, and then we do test, and we print that. Let's see. Will it work? Will it work? Unexpected that on 187. Okay. So, yeah, it doesn't want this actually. We want to get rid of those. There we go. I think that was the issue. Cannot use variable. Not enough arguments. Oh, okay. So that is actually 61. I know what that is. Nope, it is not 61, I guess. Oh, yeah, it's 340. My bad. Yeah, right in here, we need to actually pass the variable, hash map as well. Variables. Okay, let's call that. And then, can I use variable? Oh, okay, yeah. So we need to actually point, let's see. So how do you push the integer representation of a, hey, let's see. Integer representation of pointer in Go. That is what I need. Basically push the, yeah. A Go pointer as int. Let's see, can we do that? Guess int. Yeah, we might need to define a variable like that. So, yeah. Because I don't want to push the value. I want to push the actual pointer. Will I need to modify that to actually be able to store pointers? Modify, yeah. Let's see. Okay. Yeah, I want to just store this value essentially. Except, yeah, not the hexadecimal version of it, but yeah. So that is what I want to do. Let's see. Is there anything good? Pointers. Run this, and then is it gonna go? All right. So that is what it does. That's not what I want. I want, yeah. Okay. Pointer. Yes, we have a pointer to an integer, but I don't want to push the integer. I want to push the memory location, but as an integer. Yeah, this is basically what I want to do, I think. Yeah. Something like this. Okay. To a uint pointer. You need a package. Is that a standard one? Alright, yeah. Let me try that. So, let's include unsafe. And then, let's see. So this is variable. Yeah, right here. We want to. Alright, how did that work? So, you cast it like that. Okay, so unsafe pointer. Pointer. This pointer. And cast it to. Does that uint 64? Well, actually, just int. Right? Can I do that? Let's see. I need another one of these. Actually, I don't need this first one. No, that is something different. No, that's not what I meant. Now I just exit out of there. Okay, so unexpected, unsafe, an argument list. So does it not exist? Let me see. G, so it doesn't like that. Oh, because that needs to be wrapped in parentheses. Okay. I can do that. There we go. And now, okay, so then we get 0. That's not what I wanted. Unless, is that the memory location of it? So, variable again. And then, is that, okay, so it's just always 0. So is that because that is the value stored there? I suppose so. So that, so what if I don't do that? It probably won't work, right? Yeah. So that is, alright, do I need to cast it to a uint 64 and then to an int? Like that. Let's see. It needs to be like that, maybe? Or is it not uint? Is it another thing? Let's see. What was it in here? Yeah, it's uint 64. Do I need to import that? Oops. That is not what I wanted. Okay. Expected that. So, where did it expect that? Expected a comma. I do this. Or I need to wrap it up like that. Okay, a lot of parentheses going on here. Okay, yeah, so that doesn't help. Alright. Let's see. Okay. Cast it here in. That, yeah, it needs to be in pointer. Okay. And then do I need to do this again? Unexpected that. Unexpected. Okay, yeah, that's not right now. So that is not right. Okay. Um, yeah, this needs to just be in. See like that. Yeah, doesn't work. Okay. I want, let's see, am I doing it wrong? Okay. Float, that is a float. Unsafe dot pointer. What is the output of this? Let me look at unsafe pointer. Unsafe pointer in depth. That is what I'm looking at. Let's see. Yeah, so it's like a void pointer. But I want to push the value of it. So what if I just dereference and then cast it to an int? This needs to be like that actually. Do that, and then yeah, that doesn't work. Okay, so cannot do that. Okay. So that doesn't work. And you can't just cast it directly to an int like that, I presume. That might be unmet. Let's see. Yeah. So yeah. Yeah, I don't care about risks of that. I just want to push the pointer. Okay. 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 This was not very helpful. Da, da. New int pointer. Yeah, so that is uint. Okay, run that, and then unexpected that. I don't know. Uint, what is it? FB64. No. Don't get what the issue with that is. uint64. That is that. That should be fine. What is that? Okay. Alright, call uint pointer. Uint pointer. Like that. Okay. And then let's see. Alright, and then cast it to an int. And I need to do that, like that. There we go. And there we go. That is what I wanted to see. So now we should be able to, if I do something like this, it would just be the value, right? Okay. The value of type int. And I want to take the value stored at this pointer. So, let me just do pointer is all this stuff. So int of uint pointer. Let's say dot pointer. There we go. Something like that. And then get rid of all this and just put pointer in it. And that should be the same thing. Yes. So I'm going to just dereference the pointer. And yeah, okay. So that doesn't work. Let's see. Int pointer and then do that. Doesn't like that. Pointer. Yeah, I need another one of that. No. Hmm. Expected pointer. I don't know what that means. So now I want to take the value at this pointer, but I don't know how to do that. Like this. Let's see. It's just casting it to itself, right? Alright, let me see. Expected that. So it doesn't like that. Okay. So does this have a way to get the value of the unsafe pointer? Do I have to cast it to a UN and then take a reference of it? Let's see. Can I do UN64? Then do that. Cannot do that. Okay, doesn't like that. Okay. Let's see. Alright, let's see. And now. Okay. Let's see. So go. I want go. Uint pointer to. And get value at that. That is what I want. I want that. So is there dereference in here? Dereference. Okay. That's not what I want. So do we have dereference in here? You get the type of it. Oh, okay. Yeah, deref. Okay, there's nothing in here about that. So, okay. And then in here, oops, that's not what I wanted. Can I do that? Like that, actually. Okay. Type of int. So, that does not work. Okay. So, if I do that. Okay, that doesn't work. That does work. And it doesn't let me dereference. How do I dereference the... But it's just an int now, so is that why I cannot? Okay, so maybe I need to do this. Alright, so pointer. So call unsafe dot pointer on this pointer. And that's not going to work, right? The output of that is not right. But cast it to an int. And then, alright. Can I convert pointer? So this, do I need to actually do that? Let's see. Okay. Then we get the value. Alright, that is... Alright, so that is how we can get the value. So it's a little bit complicated. But then if we just put pointer in here... yeah, actually I want to save that. Just so I can remember. I'll do that. And then... Whoops. Then, yeah, we just push the pointer. Then we just get the memory address. And that is what we wanted for that. And then if we call the variable like this, and then we do add, we get the value added. We do this, then we set the value to the top of the stack. Okay. So I think I can do that. So, basically, if it's in here, then we do this. If there is not, if following it, yeah, okay. So we need to add new tokens for. So I didn't explain that very well. I will in a moment though. So we need it's at type is what it's called, I suppose, and then bang type, which is just like exclamation point like that. Okay, and then we can add these in here. So case at, and then case bang, category equals bang type, and whoops, and category equals at type. There we go. So now we can parse those, and basically we just need to check if the next one is equal to that. So that would be in the word. Let's see. All right, right here. So basically, if let's see, tokens I plus 1 dot category equals equals bang type. So should we do bang type first or at type? Probably bang type. Probably makes more sense. Then we'll do this. Else if I plus 1. Maybe I should make that a variable, actually. Category equals at type. Then we'll do something else. Else we do this. Yeah. So I think that makes sense. Alright, and maybe we want to actually declare this at the top. So, because we're going to use that for all of them, the pointer. So we can do that. So if it is the bang type, that means we're going to get the value. That means we're going to, get to the top of the stack and set the value to that. So, do we pop it though? I don't think we pop it. Yeah, let me just try. So variable balance, and then do 1, 2, 3 balance, and then, alright, so that gets the top of the stack. So, alright, so it does actually pop it off. And then if we call balance, that is the pointer, and that is the actual value. Okay, so it's starting to make sense to me. Yeah, so we do pop it off. So, we just do a equals stack.pop, like so. And then we just want to set variables of let's see, of val is that, yeah, val.value equals a, and that is, I think that's all that we need to do in there. Then in here we need to actually get the value like this. So I think I can basically just do this, right? Right. So if I do that, yeah, so that'll push the value stored at it. So I think that is it. For that. I think this is messed up. What is wrong? This needs to be equal. There we go. Okay, so that I think should work. Let me run this. We don't get any errors. So if I call that, let me actually push 12 then. We should get a stack underflow though. So maybe it doesn't work. Oops. Nope, I want to undo that and quit. There we go. Alright, so if I run that, yeah, push 1, 2, 3, run that, and yeah. There is nothing on the stack. But then I do s-add. That should, I need a dot. That pushes 1, 2, 3. Okay, and if I don't do that, then it pushes the value. And the value, should it change? Maybe it should change. Let me see. I need a new line actually. CR. Alright, yeah, so the value, the pointer is actually the same. So we're setting, yeah, okay, so that is good. So, yeah, now that actually sets the value to whatever we want in here. And then we should be able to push a bunch of other stuff. 9, 124, and 63. And then if we call test at, then the top of the stack should be 1, 2, 3. There we go. And then we should have all the other ones. So 1, 2, 3, like that. And we should go all the way to 59. And then we do a new line for each one. Bye. And then, yeah. Alright, so that looks good to me, actually. And we should be able to do it as many times as we want. So test at, then the top two should, in fact, be 1, 2, 3, 1, 2, 3. Perfect. Alright, so it is actually working. That is kind of surprising. And also, we got memory stuff. So. Actually, maybe this shouldn't just be for words. Maybe that is not how it works. I should have actually read more of it. So I think that this can be used without the word. If we just do 50 and then do that, Ooh, okay, so that doesn't work. What does that do? And then do at? At pointer. 1009 is 0, 1001 at is 0 as well. So, yeah. So, let me read this, actually. So, what is the question mark? Ooh, I didn't read that. So. That prints the value, okay. So it does the same thing, but also prints it. So, yeah. The word plus that is used to increase the value by a certain amount, like plus equals. Oh, okay, so that is the thing. But the word that stores the value at a memory location referenced by a variable. Alright, so it is only for variable references. So, but at works for any memory location. Right. So if I pop and pop, so maybe we need to do that actually. If we encounter that, then we just take the top of the stack and then treat it as a memory location. So I think that is actually how it works. It's actually drop. So I put like 1000 and do at. Yeah, okay. So I think I see. Yeah. So that is what I need to do. So not check if it's a word, but instead check if it is actually this type. And then we can just push we need to do this one. No, we need to do this one. Okay. So yeah, we just need to pop the stack and then do that. Okay. So we're pushing that of the pointer. Okay, so let me think. So we need to pop the stack and do this on it, essentially. Okay. I think we can do that. So let me just do it right here, and then I will move it to a better location. So let's just do at type. And then we can do pointer is stack.pop, and then we want to do this stuff on it. So basically, maybe I'll just do a is stack.pop, so it's not quite as confusing. And then pointer is all this stuff, but for a, yeah, for a, like that. So then we get the pointer of it, and then when it is at, so we pop it on, get the pointer value, add it, and then we just want to do this. So then, yeah, okay. So that should be fine, and then we can just get rid of this entirely. Yeah, I think that is good. Okay. So, now if I run this, it should work the same. Test at, and maybe it did not. Because that is actually printing those. So the at did not work. Okay. Why did it not work? Let's try to print this. Let me see. Maybe I need to do this the opposite way. A is that. Ooh, okay. So, test at, it doesn't work. Okay. So I messed something up. Because we're just pushing the pointer value, and that is not what we want. But A is also just a pointer. So yeah, we don't actually need to do all this pointer stuff. We just need to do that, and then do it on A rather than on pointer. Okay, I think I see. Like that, there we go. Because A is already the pointer. There we go. Yes. That is perfect. And then let me put another new line. And run this, and it should, perfect. Alright, that is looking good to me. Yeah, because now it'll work with anything. So we could put something that's not even valid on the stack, and then it's just going to be nonsense values, but it might not actually work at all. Yeah, and pointer, invalid memory address. So that's okay. That is just user error. So then we need to do these actually. So that is at and dot. So that is question. Question type. Okay. Question type, and then we can easily lex that as well. Right down here. Case of question. Open that category equals question type. Okay, and then I'm just gonna do it right after this one that we added in here. Let me get rid of that. Right after at type, we'll do case question type, and then we do the same thing, but then we also print it. So, stack.push push that, and then we call print. So, what do we do exactly when we print? print type. Yeah, so we just do this. So we just do this exact thing right here. Because they are equivalent. So we do that, and then we push it. So we could probably cut out the middleman. And by that, that's maybe not exactly the valid expression, but essentially we can just get rid of this. And then, instead of pushing it, we just try to print this. Format, print that. Yeah, so let me run that. Invalid, yeah, so that is because of this. So let me do test, and then I'll do question mark, and that should print it. Okay, there we go. So that is perfect. And that is more concise than Crickman. So we can also not store this as a variable, but I think it's probably better to do that. Easier to work with, and it's not as long lines. So, alright. Now we can do the plus bang. Increase the value of a variable. Alright, so only for variables. Alright, so it basically takes the value at the variable. Alright, so let me actually try that. Variable balance. And then 1, 2, 3, balance that. And then do balance plus bang. Stack underflow. Okay, so it takes something here. So if I do 1. Okay. And then print what is at balance. Okay, so I see. So it takes top of the stack and adds that to that. So that's pretty easy. Plus bang. But that only works on variables, right? Or on on variables. Plus that. 5 plus that. And 5 plus that. Yeah. Well, it really works for any pointers, but it's not necessarily right. Like that. Yeah. So, yeah. I might need to kind of change how this works. Basically, this is iter or plus. Really, how can I call this? Just plus bang? I'll call it that plus bang type. I'll actually put it next to the bang. Next to the bang. So then down here, we have got case of, let's see, plus bang. There we go. Token not category equals plus bang type. And there we go. And then we can just do that. So right now we'll just treat it as a word, but really that's not what we want to do, right? Yeah, we don't really want to check this. So, yeah, okay. So this, we can actually move it all out of here. So case bang type. Because it's really meant to work for any memory address. It's just sometimes it's the wrong one. So we can basically just do this. Then variables val.value equals a. So we don't need to check if it's that. We just need to do this, essentially. And I think that should still work, really. And then just get rid of the else there. And then this is just an else if for this. Why is it indented? No, okay. Yeah. So it is like that. Yeah. Okay, so then we don't have the else in. If I run this, it should still work, though. So I did something wrong. Okay. So it doesn't like that. Test. At. Dot. So maybe it doesn't work anymore. So, okay. So why is that? So invalid memory address of the pointer. So the pointer doesn't work. Where are we doing that, though? Is it? But then if we just call test, whoops, just call test like that, it should, yeah, it should just push that. So it doesn't want to do that. Because it's now index out of range. What is the index that is out of range? So in the stack.push, okay. Oh yeah, so we can't actually, oh, wait, we don't want to do this anyway. Yeah, okay. So we just do that. There we go. So that should actually fix it. Then we can do that, and we need to actually write a value here. And that should, okay, then we can do test at, and actually we can do question mark. And that will print 0, so that's not right. That is not right. So it doesn't work anymore. The bang must not work. So, bang type. We want to actually pop the one just under it. So we want to, yeah. We want to, yeah, grab the one under it. So it's like an over, essentially, is what we want to do. Because when we encounter this, we push the pointer to it. Okay. Actually, that's not right. Yeah, so this is a bit more complicated because this is not being set properly. So, we want to grab that. Yeah, we kind of need the word value. So, yeah, okay. We can just move back to how it was, for now at least. So, yeah, let me just undo what I did there. And move that back into there. And there we go. So now it'll still work. Should still work. Yeah, 12. So that is what I wanted. And then, we're doing the plus bang. So, we can just treat that as this as well. Else if, whoops, I need to do one of these. Else if, tokens I plus 1 dot category equals, plus bang type. Then we are going to definitely do some stuff. So, how does it work here? So we want to, let's see. So, balance, let me drop that actually. Yeah, do balance. And then, yes, do 5, balance, that. No, that one. And then call balance. Okay, so it just modifies the value stored at the pointer. So it is basically dereferencing it like this. Okay, so we can actually do that. So we can do this, but for pointer, A is that, there we go. For the pointer rather than A. For the pointer. Okay. So something like that. And then we get the value stored at it. Then we want to iterate it. Or maybe we could just index the hash map. Yeah, I think we can do that actually. So we do variables. That value equals variable plus, yes, we need a pop actually. So A is stack.pop plus equals A. Plus equals A. There we go. That should actually kind of do it. Expected plus equal at the end of statement. Don't know what that means. Do I need to do something like this? Actually, yeah, we don't need the plus. So we can just be variable plus A. That is actually correct. So if I run that, we get 12. But if I do test plus that, and we actually put a value here, so like 5, then it should be 17. Perfect. That is actually perfect. It does work. Yeah. Okay. That's pretty good. And let me just, so that still works. So then we can put a new line here. It'll put a new line. And we can just do at and then print, and that has the same effect. Yeah. This is pretty good actually. And it should work more than once. Okay. So that seems to be working. And I think we've got that. So constants. Now we're doing a similar thing, but it cannot be changed. So it just represents value. So this is basically just a hash map that we just get the value from. So yeah, that's that should be actually pretty easy. So let's make a constant type, and I'll put it right here. There we go. And then we can parse this, or lex it rather, the same way. Case is constant. Token.category equals constant type. Okay. And now, okay. So, oh my gosh. Alright, so if we encounter constant type, case constant type, then, yeah, we're going to need another hash map. Or, well, actually, could we just use the same one? But make it, probably not. Because we'd be, so we need a way to actually tell if it's constant or not. So, yeah, actually, we're going to want a different one. So basically, just do constants, now that value equals, stack.pop. So, yeah, so we need to do the same thing, though. Val equals tokens I, and then we can do A is stack.pop, and then, there we go. So that'll say, we need to actually initialize this. So we'll do this the same way. And again, all this will be moved into a struct. Yeah, I'll put it into a struct. So it's all contained in there, and we just pass the structure in here. And that's that's it. Maybe like the tokens too. I'm not sure exactly, but well, that'll be once all of the features are pretty much implemented. So, yeah. So now we just need to accept it up here, and oh, we also need to add it here. So, where we actually call this constants. There we go. And then yeah, we want the same thing here. So let me actually separate it like that. And then yeah, we will have constants, which is a map, same thing. There we go. Run that, and we have a problem. Okay, I didn't actually add it to here. Constants with an S. There we go, and that should work. Okay, so now if we get rid of this stuff, and we declare a constant, nope, I didn't actually add ways to retrieve the value. So when we encounter a word, we want to check if it is in, can you actually have conflicting names? Let me do, variable answer, and then constant answer. Oh, we need to actually put a value for, and then if we call answer, what does it do? Just the most recent thing? Ooh, that is interesting. So we get 4. Yeah, okay, so that's a little bit conflicting. So I'm not sure exactly how I'm going to handle that. But in here, yeah, so we kind of want to put it into both. But I guess the most recent takes precedent. So put it in one and then remove it from the other. Okay, well, I'm not sure exactly, but for now, constant okay is constants val dot val. So this is cock, okay, C okay. So we'll check that one first actually. If C okay, else if okay. Yeah. So if it's that, then we'll just push the value. So stack dot push constant. There we go. So if I run that, we don't actually have a thing. So constant answer, and we need a value here, so 5. And now if I run that, it should work. And then if we push answer and print it out, it should be 5. There we go. So I don't know exactly what's gonna happen if I do variable answer. Actually, so the constants will take precedent. So yeah. Yeah, okay. But they are both technically stored in there now. We just don't have a way of knowing whether it is what. But yeah, we need the precedence to essentially be whatever was done most recently. So, okay. Okay, so basically, yeah, okay. How can we do that? So, if we, that is going to be a bit strange. So if it is already in one of them, then we'll just remove it from there. So then, yeah, it doesn't matter the order that we do it. So I think we can do that. I think we can do that. Yeah, down here. So, yeah, we'll basically just want to do this for both of them. So let me just copy this. Okay, just yank this. So in here, we're going to want to do this. So for this one, we'll do that. So constant is val.value. And then if that, then we'll just set it equal to nil. So I think we can do that by doing constant val.value equals nil. And then we can just continue doing this. And that should remove it. That should remove it. So then I'll do this here as well. Except this is variables. So let me see. Okay, so that doesn't work. Alright, is there a way to remove value from hash map? Go remove value from map. That is what I would like to do. So how can I do that? Let's see. Okay. Okay, so you just do delete. Does that work? Can we do that? Delete. Constant val.value. Alright, and then do this but for variables. Variables like that. There we go. Run this. And that doesn't work. Expected to. So we need another one. Okay. Oh, okay, so you provide them like this. Alright, that is okay. So, I can do that. Alright, and that should remove it. Constant declared and not used. Oh yeah, so this, we don't actually care about the value found here, so I can just get rid of that. Whoops. Yeah, there we go. Alright, so now we get the memory address, and then if we change that, we'll get 5. Perfect. Okay, so that now works. That now works properly. So that is pretty good. Pretty good, I think. Let me actually commit this, and then we will do the rest of the stuff. So, let's see. So, fix the label error. I actually did a lot of stuff. I should have done one earlier, but that's alright. Fix the label error. Added variables and constant. Here we go. So I will push that. There we go. And should be right here in the repo. And perfect. Okay, so now we can actually look at arrays. So we need to use the aligned keyword. So I need to figure out how exactly that works. Okay. So there's cells as well is a keyword. Okay, cells just multiplies the cell by the cell width, which is 1. Okay, so how does it know the cell width? Okay, so variable, let me just see what this all does. Variable numbers, 3 cells aligned. Okay. Whoops, and alright, right here. 10 numbers, 0 cells left. Bang. Okay. So, not sure what exactly that means. Not sure what exactly 1 cells. Alright, and then we have 10 and 20 on the stack. But then, alright, so if we actually call numbers at, and we get 0. Okay. So drop that. Okay, so this example creates a memory location called numbers and reserves 3 extra memory cells after this location. Okay, so actually, so that is just hard-coded is 1. Okay, so not in this, in this implementation of fourth. Alright. Okay. So, multiplies by the cell width. So, that basically means 3. It allots 3 places for it. Okay. Numbers 0 plus. Oh, okay, so actually I was doing that wrong. So that needs to be like that. Okay. Then if I call numbers at, then, alright, so then we get 10. If I do numbers 1 plus at, then we get 20. Okay, so that is actually how that works. That makes sense, actually. So, alright. Could easily write words. So, alright, offset and address. Okay, so that makes sense, actually. So this is basically setting the index of the array. Okay, so we need to allocate space for this. Okay. So 3 extra memory cells after this location. So I'm not sure exactly how that would be done in Go. Because we have its physical or its actual memory. We're not having simulated memory. Should I be doing that though? That might be the better way to go. So sort of change it so it uses an index of an array. And that is where it is all stored. I could do that. So basically another stack, essentially. That might be better. Well, let me see. So just kind of like go reserve memory. Is there a way to do that? Well, I guess, yeah, we could just, so, yeah, I don't know how this all, like, I know how to do this in C, but in here, create slices, maps, and channels. Okay. Oh, okay, so we basically could do that. That would work, actually, and then if we add 1 to it, 1 to the, yeah, okay, I think, I didn't realize make had a second argument, but new doesn't. Okay, yeah, I think we could do that. So basically, when we call that, we make that, and that will reserve the memory for it, and then we can just push the value of that. Okay, I think we could do that. So, yeah, we're setting. Yeah, so that's a little bit harder to do though, because of this. So, it's a little bit complicated. Okay. So what do? Okay. Yeah. 3 cells, a lot. Well, I can add the keywords. That'll be pretty easy. So we need cells and a lot. Yeah. Nope, that is not where it goes. It goes right down here. So cells type and a lot type. Cells type, a lot type. Okay, okay. Yeah, then we can lex it down here. So case cells. I feel like a lot should actually go first. Open that category. Category equals cells type. In case a lot, then whoops, do this, but on a lot type. Okay, so we got that. Okay. So when we encounter that, we want to allocate space for it. But how does it actually connect to numbers? So, yeah, I think we're gonna need simulated memory. So I think now is probably a good time to make a struct, actually, for this, rather than passing everything like this. But first, I'm going to take a quick break. Quick break for about 3 minutes. So I will be right back. Okay, I am back, and with 55 seconds to spare. So, let's see. So, basically, I'm going to be making a struct now, and then I'll add the memory. So, let me just do that. So, type. So what is this? This is basically, it's called Gorth. For now, that is what it can be called. And this is a struct. Okay, so what we need in here, I don't know that we'll put the token list in there, but we'll definitely have the stack here. So stack, yeah, stack. Probably a pointer, like that. And then, yeah, we definitely need the map. So, yeah, we can do this. The map of tokens. That is, yeah, that's the number of words. And then also is word, which is a bool. Basically, everything that we have in here is what we are moving into here. And then the current word, which is a string. The variables. Yeah. And then maybe these could have better names as well, but yeah. And then the constants as well. And the memory will go in here as well. Yeah, so I do that. I probably won't initialize it here, but I'll leave it there for now. And then we can just get rid of all of this stuff. And then just pass. Well, yeah, we can make this part of the Gorth struct. So, let's see. I don't remember exactly how to do it. I think you do something like Gorth. And then we don't actually have to pass it. Something like that, I think. I actually do it up here with push, so I can look at that. Yeah, that looks about right. I do put a space here. Okay, so then that should be connected to it. So we can initialize a Gorth down here. Down here. So yeah, we can do Gorth is a Gorth. Okay. And then we can just do Gorth dot interpret tokens. And just pass the tokens in there. So then we can also get rid of these. So basically, yeah, the current word in stack, we don't need to do anything with. These the maps we actually need to initialize. We can do gorth.words. Hello, you doing this all in one file or sync? Well, it's all in one file for now. I'll probably separate it out into multiple files once it's done. It's not very big though. It's only 500 lines. And I'm not really parsing at all. It's really just lexing and then interpreting it. And I don't know what sync means exactly. What do you mean by that? Sync. Yeah. Okay. Yes. So we can do that. And then it's not gonna work because, you know, we go run and then go on test. Saying just another word for something in my mind. Long day. Okay. Alright, yeah, I see what you mean. Yeah. Okay, so, yeah, so basically, what is this? Instruct type. I think I messed something up. In here. Is it actually, let's see, how do you declare a struct again? Did I mess it up? So, alright, so there's no commas actually. I forgot about that. Something for clarification. Yeah, it is in one file, yes. Yes. Bowl. I messed that up. There we go. So now, yeah, now we have some problems because we need to actually do gorth dot whatever. So this is actually in here. No, I guess it's not. So yeah, these are just done on the function level, so we don't need to do anything with those. The loop should go in there though as well. The current loop. I will change that afterward. But we can change all the places where we have these problems, and we just need to basically do gorth dot that. So in word is not defined in there, and it probably should be, but this needs to be that. Let's see, could I just query replace? Perhaps. So I can just select all this. Alright, yeah, so stack is a big one because we use that a lot. This is actually a whole lot of stuff. So yeah, just replace this, and replace stack with gorth.stack. And hopefully that didn't mess anything up. But it should work. Should work fine. And then this is also gorth. Some of them we don't use very often. So it's not very easy to, or it's not very hard to just replace it, and it's probably faster than just than going through and changing everything. So yeah. That's all good. Alright, so let's see. That is one big switch statement. Yes, indeed. Right now I'm not really worried about making things efficient. I'm just trying to get it working. And then I'll go through and clean up, maybe add 1 or 2 files, clean up some of this, because there's a lot of unnecessary stuff in here that I do. But yeah, I'm just trying to get something working right now. Yeah. Okay. So what else do I need to replace? Let's see. So yeah, there's a lot of stuff here. So undefined interpret tokens. Where? Oh yeah, so we actually call that again. Interpret tokens. Right in here. So we need to do that. There we go. That can be gorth. Gorth. Okay. So variables is not defined. So variables. Let's see. Okay. Yeah, right. Gorth. Maybe there's more of these than I thought. Okay. Gorth.stack. Okay. Yeah. Here as well. Okay. And there we go. And now, okay. So in here, that looks fine. Alright, and let's see where else. Too many errors. What does that mean? Does that mean there's just, okay, I don't know exactly. So this, whoops. Do that, 4 or 5, okay. Gorth. Alright, so now is word. Yep, okay, and then that is 383. We actually have a few of them. So this, yeah, okay. So this we don't actually pass any of these things anymore. Just the words val.value. But we also need to set Gort.inWord equal to true. And so I'm thinking maybe that shouldn't be in there because it should be false by default. So yeah, I'm going to actually change that. So this will pass true in there, and then I'll remove it from here. So oh shoot, actually, yeah, I didn't put it in there. So true or in word rather in word bool. There we go. So now that should be fine. We need to add it here though. Yeah. So then, too many errors. There's a whole lot now. So 457. Undefined variables. Oh, okay. All right. Is word is undefined. Okay. Yep. I should just use query replace for it, but now I can't, and it's gonna make even more problems. Okay, so Gort.words on the left side of that. Okay, so I can do that actually. So I think I need to actually do that when I initialize it. So I can do something like Gort is that, and then put these in here. Will that work? I forget if that is how you can do it in here. I get rid of those. There we go. So I need to do dot. That does not need to do that. Okay, so if I do that now, that still doesn't work. How do you do that again? So, let me just do go struct, and just initializing a struct. Okay. Alright, so just wants us to set it like that. Is there not a way to do that? I don't know. Perhaps in here. Nope. Alright. Okay. Alright, just go initialize struct. Okay, so this, so that is how you do that actually with colons. Okay, let's see. Does this work? Variables. Actually, maybe that won't. Maybe this is not the way to do it. Yeah, it doesn't like that. So, it does need commas though. Okay, I'll just put it back the other way, and then yeah, then I'll just set it. So back like that. Get rid of this, and then do that, and just set. And I can do this. Variables equal. Yeah, I'll change this later. Alright, that should work though. Okay, yeah, now we're back to that. So okay, this is that. I think we are getting close. Getting close. Let's see. This needs to be Gort.words. Yeah. Okay. Yeah, this is, whoops. Alright, and let's see. Alright, so 361. Is that, yeah, that is actually, and that is not in there, so that is good. 4. Yeah, this needs to actually now be that. Alright. Stack. Okay. This needs to be, yeah, like that. And then, yeah, this can be like that. Okay, now, no new variables on there. 219. Ooh, okay. Is that right? I don't think that's right. Huh. Actually, inward equals false. Actually, I think I messed something up. Is word. No, is word. There we go. I think that is what we wanted to pass, actually. So, so we have is word in there. Alright, so actually that's probably fine then. Yeah, we just need to leave it in there and then get rid of it from here. So actually, yeah, I was right how it was. So, yeah. Then we pass true there, but I actually want to just do gorth dot, is it is word or inward? Inward equals true. Okay, and then we'll pass, we don't need to pass anything now. Okay. So that should be fine. And then back down here. Yeah, so I had it right before. So yeah, we can do gorth dot inward equals false. If we want it to be false by default, just go up here, right here. So it's is word, not inward. So I need to change all of that now. So okay, all right. So is word. Whoops. Is word. There we go. And then down here, I need to change that to is. All right. So now it should work. Inward is not defined. Okay. Inward, but inward, oh yeah, because I didn't actually, because I changed it up here and I should not have. There we go. Just like that. Perfect. Now, invalid memory address. Okay, so it seems to have broke something. With this. But I'm going to be changing this anyway, so it doesn't really matter, but variable answer, and then 123 answer that. Answer that. And actually that. There we go. So let me run that. And let's see. Alright, so yeah, now that is broken. So why is it broken? So that actually breaks. Yeah. Okay. That is not good. What did I do to break it? Doesn't really matter because we're changing it all though, but I kinda want to know why it broke. So that is where we're dealing in here with words. Okay, so this is if it's in there. So actually, which part breaks it? Is it declaring it? No, so that is fine. So it's just when we call it, let it push it onto the stack, it does not work. So, why is that? Actually, that is index out of range. Alright, so that is here. Funny name. Okay, so in here, it's right in here. So that's the variable. But this value is not a thing. Why? Okay, so let me do. Can I do that? And will it get to this point? It does. Okay, so we do have that there. Why does it run out now, though? So, am I doing something else wrong? Did I forget a gorth? Okay. So, it is this one that stops working. So when we pop it, and then, no, it is just this one. That's my bad. So when we set it like this, it doesn't work. But this works. Huh. Okay. No, so it's right here that doesn't work. So we try to push this. Yeah. That is where it dies. Index out of range of 3. So where are we indexing? Oh, you know what? It's because of this. Yeah. Because there is no +1. So that is why that is happening. So I need to fix that. So, Yeah, basically, we need to check if that is the end of the tokens. So, yeah, we can just do if I plus 1 is greater than length of tokens, then do not do this. Let's do that. Yeah, so then we can just do both of these in here. And then just move this one to be in here, I think. That should be fine then, because we know that it is not gonna be either of these. And something is messed up now. Okay. So that is for that. Okay, I think that's fine. Else, yeah, we'll indent this actually. So indent that like that. And this closes, that should not close there, so we need that. Okay. So that I think should work now. Right, let's see, get rid of that. And then, okay, so I need to do greater than equal, right? Yes, okay. So we do make it in here now, and that will work fine. Okay. Now we get, now it is the problem with invalid memory address. Okay. So that is right here. So we don't make it past there? Yeah, so that is where it breaks. So when we try to push it, it doesn't work. Huh. But it was working before. Okay. Why? Why does it do that? Yeah. So it doesn't like the memory address then. Did I actually mess something up in the declaration? So let me go to variable type. There we go. So val is that. And then if that, then we delete it. Yeah, so we set it to 0 by default. So the pointer should be to this. But it doesn't want to be. So why is that? Okay. What if we do a constant though? Does it work? And then put like 5 there. Does that still work? Oh, whoops. Wait, okay, so if I run that, no, it doesn't work. So, wait, why does that not work? Invalid memory address, but that should not be a memory address, because it is just this. So, I think I messed something up in here again. Yeah, because it should be doing this. So that should just be fine. Okay, so we don't get here. So why is it adding it? Did I mess something up down here where it is setting it to the wrong thing? Because this should just be constants. It shouldn't be memory addresses at all. So I don't know. Huh. Okay. What if... No, okay, so that's not... I didn't think so. Yeah. So when I do the constants, it should be here, but it is not. So... variable... There you go. I call that. Do we get into there? No. So now it's... Now it is doing that. Yeah, so they're actually before this. So it's in the constant type. Constant type. In here, it starts with, ooh, it's because of this. Okay, do that. Okay. So yeah, we don't even get to there. Okay, so something is definitely not right. Because Does it even push 5? Does that even work? I got it. No. Alright, so there's something else that is messed up. Oh, okay. I guess if I read this. So, in here, 489. Actually reading the error message. Probably a good idea. Alright, so that's where we call it. And then 249 is right here. So it can't push the value. Do we need to do... Ooh, we need to do that. Oh my gosh. Okay. That's what the issue is. So we need to replace... That is it, right? Let me make sure. Because now we get... No. Alright, so gort.stack. Yeah, but then it should have a dot stack. No, maybe that's not it. So what did I call it? Something different. So we have the stack in here, which is... it needs to just be that, right? There we go. Okay. That is what the... That's what the issue was. Okay. Fine. So now they should work, and this should print 5. That language is already better than JavaScript. Which one? You mean fourth? Or... I mean, most languages are better than JavaScript, right? Yes, fourth. Yeah, well, fourth is pretty nice. Pretty low level, though. Like, compared... Well, this one, it's pretty slow, but it's rather similar to, like, an assembly, stack-based assembly, which isn't really comparable to JavaScript, but I get what you mean. Yes. Okay, so... now it should work. Alright, so now we can do the memory stuff that I wanted to do. So we can just add a memory here, which is just a map, map of integers with the key of an integer. So, yeah. So we're going to replace all the places we use memory with that. So we're not going to have any actual pointers. Instead, the pointers will be indexes of the array. So we need to actually initialize it down here. Memory. Make, map of int of int. There we go. And then gort.memory. Okay, so yeah. So we have that now. So then we can do, let's see. So anywhere that we do that. So mostly that's in the words. So here, yeah, right here. So basically, this is going to get the index. Yeah, so, so that'll push, let's see. Let me start actually with the declaration. So right here, maybe it's not there. So, trying to think how to do this. So instead of getting the pointer like that, we want to get the index in the memory way. So that needs to actually be set. Yeah, it needs to set that. Yeah, so maybe the memory. So it'll have an integer, and then it'll actually return. Let's see. Trying to think how to describe this. Basically, we're simulating the memory. So here, well, actually rather here, because that is not that. So instead, we need to do dot memory, and then just the index. So I think we need a memory size. So basically, dot memory size. Yeah, we're basically pushing onto the memory. Basically is what we want to do. Equals, yeah, equals that. And then the memory size is actually what we use for that. So, yeah. Okay, yeah. And then equals 0. And then in here, we want to actually push the memory size. Like that. Yeah. So that's what we want. So when we get that, we get the memory size, which is essentially the pointer to this, to the value. So when we push that, we get that. Okay. Yeah. I think I am getting it. So in here actually. So yeah, so that should be fine. And that should still work. So now, instead of getting the pointer like this, we do pointer equals. So we want to use the pointer equals variable actually, because now the variable is no longer the value. But the constant still is. The constant still represents the value. So there we go. So that's the pointer. It's not, yeah. So then, yeah, we want to push the pointer if it is that. Otherwise, if it's the bank type, then we want to set the value at the pointer. So, yeah, this is basically setting that, but instead we want to do gort.memory, let's see, of pointer equals a. There we go. And then this is actually gorth.memory at the pointer equals variable plus a. And actually variable is not valid anymore because we need this to rather be yeah, so pointer is variable, so we don't actually need to do that. So instead, yeah, instead this should really be the pointer, and then variable we can actually initialize as the index of let's see, of memory. With that memory pointer, yeah, so that is the actual variable. So then we can use that here. So yeah, that should work actually. And then we don't need to do this. Okay, plus a, and we don't have a anymore because I actually got rid of that. Gorth.stack.pop, just like that. Okay, perfect. So that will iterate it. That's honestly pretty complex Go. And you just followed. Thank you, I appreciate that. It's not very complex really. It is pretty simple. Like compared to some other things, but yeah, I don't know. It's pretty fun though. So yeah. Alright, let me see. So I think that'll work now. The only problem is that we don't actually iterate. We don't iterate here. This needs to, then we can do gorth.memory size plus plus. Yeah, so that should be fine. So we do need to add memory size, but we don't actually have that. So gorth.memory size equals 0. And then I can add it to the struct. I know it exists, but I commonly use Go for DevOps and backend. Yeah, usually you're not working more like really with memory. In backend, right? As far as I know. So I could see how it would be complicated compared to some things like that. But backend can get pretty complicated as well. So yeah, memory size, is there like an unsigned int? Yeah, maybe I should use that instead. Memory size. Oh yeah, maybe I'll just do it. Because that will be simple. Okay, so I don't know if it's going to work at all. But we can try it. So let's just make a variable. Just call it whatever. And then set it equal to 1. And then we can get that and print it out. Alright, so let's see. Yeah, so stack underflow. So it did not work. If I do that, stack underflow. Okay, so answer. What does answer have? Answer did not push anything. So when we call it, it didn't work. Okay. So that's not particularly good. Let me see if I can figure out why. It must not have been okay. So let me actually try that. So log.fatal. Yeah, I'll just do pointer. There we go. And then, alright, so we did get 0. Now lang has a specific use case, or is it just for fun? Well, so it's actually, it is Forth. It's an existing language. It's been around, I think, longer than C even, since like the 70s or whatever. And it's stack based. So I'm just kind of implementing an interpreter for this, trying to have it be fully featured. And I'm just really doing it for fun. It's not for any specific thing. It's really for fun and learning. Well, I'm learning about Go, first of all, because I'm pretty new to Go, and then also learning more about Forth, because it is quite an interesting language. But mostly for fun, yes. Okay, so yeah. So that actually worked. We did get here, and we have the pointer. So I messed something up in here. So let me see, do we have the variable here? Okay. So the variable is 0, which is not, well, actually that is correct initially, but then when we set it, it shouldn't be 0. Yeah, that should be fine, actually. That should be fine. So then, yeah, so we should have this bank type in here. So let me do that. Okay, so if I run that, we get 0. And let me actually see what A is. So A is 1. Okay. And then let me do gorth.memory pointer, and it should be 1. Okay, so that is good. So I think it might be with the way I'm getting it. So pointer is that. So that's the value. Okay. And then variable is that. So let me log this. Log.print line variable. And we can see all the iterations of it, and it won't crash. So we have 0 and then 1. So yeah, that should be fine actually. But then there we get an underflow. So why is that? Because when it's 1, that is actually when we're calling, actually, should it ever be 1? Oh, shoot. I think I know what happened, actually. So, maybe not. Yeah, I don't know. So, okay. Go with that variables. So the variable still has the string, and that should be to the pointer. And that should, okay, yeah. Yeah, so that should be 1. That is correct. So then, it should be assigned in here. But it shouldn't be 0. Should it be 0? No, it shouldn't be 0 in, when we're actually retrieving it. So when we push it, yeah, hang on. I'm trying to think here. What is, it should be pushing something though. I like the arch, by the way. Yes, thank you. There we go. Neofetch or Pfetch, which is better? Yes, arch is very good. Okay, let's see. So, why is it not working? That is the question. Okay. Okay, so, when we encounter it without any, yeah, so right here, actually, we're pushing the pointer. So this, when we encounter this, it is 0. So that is correct, and it should be pushing 0, but it is not, or it gets consumed at least, immediately following. So that should be equivalent to this. That should be where it fails. So if I actually do log.println variable here, then we should get, yeah. So we do get that. So 0, 1, then 0. But it doesn't actually push it. We can't pop it off. Why does it underflow? Okay. I'm not sure why, because we're getting there. I know that. Stack.push, something like that. And let's see. It's still stack underflow. So why does it do that? Then we print out 5. So it's not pushing anything. It is pushing nothing. But we are using that. So am I doing that wrong? Let's see. In the push, yeah, stack.push value. I don't understand. Okay, so let me do org.stack. Let's see. Let me do that. We get 5. Yeah, let me get rid of that actually. Okay, stack underflow. Let me actually get rid of that as well. So what does it do? It prints out 0. So it is on there. You also use Arch, by the way. Sorry, I just saw that now. Very cool. Arch. Use vanilla Arch or a distro like Artix or something. Okay. Gorth.stack.pop. So it lets us do that there, but it is not remaining on the stack. Why? Get rid of that. Why does it underflow? I don't understand. So, okay. Gorth.memory pointer. We're pushing it. We can pop it off in here, but then it is gone. So, I don't understand why. Where do we pop it off somewhere afterward though? Is it something I messed up here? Okay. Because we don't pop anything here unless we get into one of these. So let me actually do, let's see. Guess I don't need to use log for this, but that's okay. So I'll do that, and then I'll also do, let's see, fetch. And then I will do it in here as well. Because these are the 2 instances of pop, and I will see if which one comes first, essentially. Pop. I know it's not the best, but I use Arch in WSL. I hate Windows, but it lets me have the best of both worlds. All Windows apps not available in Linux, and Arch stuff in the WSL. Alright, well yeah, that's perfectly fine. You know, whatever works for you. Alright, yeah, so pop comes there. Then push. Yeah, so we don't actually get to this one, so I don't need that. Yeah, so pop and push. Yeah, I've never actually used WSL. Yeah, because I just, when I heard about Linux, basically, when I started using it, I just switched over entirely. Because I didn't use a lot of Windows-specific apps. Yeah. Okay. So, pop and push. So we pop it off here. That is setting the value at it. What if I just do that? Get a push. And can I do that? No, it's stack underflow. I don't know why. Oh my gosh. Okay. Okay, so we only push. Because that should just be pushing the index of it initially, which should be 0. Which doesn't push. Doesn't push. Doesn't push. I don't know why. Okay, so is it in here? Okay. With that memory. Did I mess this up? Memory size plus plus, that should be fine. It's initially, it started at 0, right? I did do that. Yeah, memory size starts at 0. Equals that. So that should be 0. That should all be fine. I don't see the issue. Okay. Gort.variables. We have that in here. Okay. Let's see, but then constants work, right? Just like that, and then print it out. It works perfectly fine. Yep. Okay, but then variables do not. It doesn't actually push it. It says it pushes it, then it doesn't push it. Why does it get consumed immediately? So we do that. Let's see. Then, did I mess up a closing one? So, okay. Where's that variables? Yeah, so this gives us the pointer. And then we skip through this because we don't have any constants. And then else if okay, variable is that, so that'll be 0. Because that is what the initial value is. And then we get here and we push. And we don't ever get into here, right? We don't ever do anything in here, right? Yeah, so we don't. So then why does it get popped off immediately following? Is it, let's see, something with this. What is this? That corresponds with that, so that should be fine. We should skip over this because we know that we get that. But this isn't popping off anyway, so that doesn't even matter. Let me print each iteration, and I'll print what each of the tokens are. So, let's just print it out, and that'll print both the things. So we have variable 31, answer 23. So, yeah. And that's it. If I add a dot in there, it might not print because it's going to fail, but yeah, dot 17. So, why does it stack underflow? I don't understand. Stack underflow. So we're trying to pop, but we can't. So, where do we do? Where do we call dot pop? So in there. So that's not anywhere that is relevant to us. Yeah. None of these matter. So it's only the ones that we're calling. So variable, answer, and well, dot obviously does pop, which is the print type. But that doesn't matter because it should be on the stack, and it's on the stack at the end here. It's probably something super obvious that I'm missing because here we can push it, or here, look, we can actually. Is it a spin-off of Forth? Well, no, it's just meant to be an implementation of Forth, entirely. Like, not different at all, like, not like Porth or anything. It's just, I'm trying to implement a fully featured Forth interpreter, essentially. Yeah. So it is Forth, but not a spin-off. I just call it Gorth because that's the name of the interpreter, but not the language technically. So, yeah. That is what it is. So let's see. Yeah, so we can print it here, and that works. That works fine. I print it there. So we stack underflow there. Get rid of that. Now it'll print it out. Prints out 0. But so we can pop it here. Is it not iterating the stack size? Did I mess with the stack size? I shouldn't have. Stack size. I don't have that anywhere. So stack size. Oh yeah, it's gorth.stack size. So I don't use that anywhere except for there, I suppose. Yeah, or stack.stack size in the actual function. Yeah, and that is fine. So less than 0. Okay. Yeah, that is not right. So let me do less than or equal to though, because we can't have both. Yeah, stack underflow. Actually, so this is in the word type. Word type. There we go. In here, let me not pop it on. There. And then do that, and change this. Let me just see what that does. Yeah, index item. So why is it? Let me print the stack size in the word type. Let's see. So where is it that we are appending? Not there. So right here. Let me do stack size, and let's see what is it. So stack underflow. Hang on. Are we using 2 different stacks? No, shouldn't be. We don't ever actually set up the stack, do we? So maybe we should initialize a stack and then do something like this. So it's still underflows. So that didn't actually change anything. Yeah, I didn't think so. Type. Alright, and now we don't ever actually get there. So yeah, what is the... Alright, so it is 1. That is the stack size at the end of this. So when does it become 0? Let me see. Let me print it up here. Not as a log.fatal though, but just as a print. It doesn't have to be log, but it doesn't matter. Okay, so the stack size 0 and then 0. So it goes back to 0. So it goes back to 0 after this. After we set it here, we push. Why does it become 0? Let me go into stack.pop. And then actually no, it's just pop is what I want. Right here. This. GDB, yeah, I'll probably go to that if I can't figure out in a second. I never use debuggers. I don't know why. It's just a bad habit that I have to not use debuggers. But let me see. I think this could help a lot. So I'm going to see how many times I am in there. So we don't actually call it 1 time. That's not right. Because we should be calling that with each one of those. So that's a little weird. Let me get rid of that. Yeah. Ooh. Okay. We don't call pop. Or did I put in the wrong function? Yeah. So that. Okay. So it's not calling pop. All right. So maybe I will do GDB. I don't know how you do that with Go because I haven't done that before. Yeah. I'll have to. Does it just work, or do you have to use a special flag? Let's see. Okay. And then break on load. function main is not defined. So maybe it will not work. Let's see. I'm not very good at using GDB because, like I said, I don't ever use it. So, ooh, yes, we need to use that flag actually. So, how do you do that? Main and then test out. Let's see, will that work? So, okay, so that, all right, compile with debug flag. Okay, quit. Yes, there we go. So, all right, so, whoops, not that. Go build, main.go, like that. Name files must be go file. All right, what is the, how does it work? Go debug flag. Yeah, this is what I want. So, okay. Go build, okay. Okay, so they contain it by default, it says. Yeah, but the issue is I need to provide a file. I don't remember how to add command line arguments in GDB, so I think I'll just remove it from here. Instead of looking that up, I can just do, instead of that, I can do file name equals test.quote, because that's what I'm testing on. So I'll just do that, and then I'll have to remember to change it, but main. Okay, and then can I do great name? Main is not fine. Okay, so will that work? Let's see. Okay, no. So I didn't recompile it actually, so that is probably why. After binary filing. Yeah, that didn't work. Okay. Undefined file. Alright, so now I mess it up. Because this needs to be like that. There we go. So now I can build it. And then GDB main. Okay, and then whoops. Run. No. Okay, so that doesn't work. Because there's no break. So I'll just break on 0. No line 0 in the current file. Huh. Okay, so So okay, list. So that is what we've got. Oh wait, break on 1. Yeah, it's not 0. So 1. Yeah. Breakpoint 2. Alright, so now I'll just run. Okay, so main. And then let me just layout. What is the layout that I want? Let me just do 2e enable. 2e enable. Or is it enable 2? Alright, yeah, so let's do that. And then next. Contents. Alright, so that is reading it, so that is all good. And then iterate through that, so that's all good. I want to let's see. Go look at the line number. I might need to do that. This might take what should be almost done. Okay, so now this is C. Okay, so yeah, let me actually add that breakpoint. Yes. Okay, so let me go into main.go, and then what is the line number of the function? So it is interpret token. So that is 222. Okay. Break on 222. Whoops, that is not where I want it. 222. There we go. And now I'll run it. Yes. Okay, so now it's next. Alright, so we're iterating through here. Alright, so we're pushing to the stack. So can I just do fourth.stack? Okay, so that shows the stack size. And then that should, it didn't increase anything. It didn't change anything. So plus. Okay. Alright. Let me actually print. Let's see. So I want growth.memory size. So that should be alright, so it's 0. Let me print growth.memory. Let's see, can I actually print the index of it? So print growth.memory 0, like that. So actually I think I might know what the issue is, at least partially. I'm using a map, but this could just be an array. Yeah, that actually might be it. Okay, I didn't actually think of that. Let me keep going. Alright, so that should push. Wait, is that something different? Yes, that is a different thing. Why are we on iTech? Okay, and then we get in here. So now the stack should go up. Okay, so now we're going to see stuff. Okay. I don't really know how to use GDB, so I do apologize. Let's go through all this. Alright, how much stuff? Alright, okay. So this is the logging thing, I think. I think that is what we're going through here. I could probably get rid of that. Alright, let me do that. So, something I will do actually. This, yeah, this doesn't need to be a hash map like that. It can just be an array. Yeah, memory can be an array of ints. Yeah, that should be all. Use S for a step, I think. Is that, so that's different than, next step? Okay, well, hang on, I think I might be able to get it to work. So let me try that, because I completely forgot about that. But then we need to actually change it in the Gort struct. So, in here, yeah, this can just be an array of integers. So, like that. Go dot name. That I completely messed that up. Go run main dot that is what I wanted. So that doesn't work. So how do you, let's see. How do you define that? It's just like that. Undefined memory. Let's see. I don't use debugger that frequently. It's only for very rare bugs. Well, usually, I guess if you get really good at it, it might be worth it. But a lot of the time, it's faster. Yeah, to just use like print. Especially if it's just a rather small thing. Expected type. Yeah, so that doesn't work. I forget. Let me look at. Well, I don't know that I use just an array anywhere. I think I do actually. So, actually, do you do it like that? Because I use the token array, so I can look at that. That's up here. Let's see. Interpret. Yeah. So, it's just like that. So I don't know why that doesn't work for mine. Maybe I need to declare it like that. So, their memory is like that. No, it's the other way around. Int. Okay. Undefined memory. So that is in here. Okay, let's see. Now we get an index out of range. So that is interesting. So that is in here. Okay, Gort.memory side. So, yeah, so we need to actually append. That is what I want to do. So do we need a memory size thing? Because I don't think we ever are gonna pop from it. So yeah, we can use append Gort.memory 0. And then, yeah, we might be able to just get rid of memory. Oh, well, yeah, this does the same thing, right? So, yeah, that'll be fine. And then for the size, we can just do len of Gort.memory, right? I think that'll work. So, yeah, just len of Gort.memory. You never pop from it, so that should be fine. So, yeah, I think I can get rid of that. Memory size is that. And then, okay, get rid of memory size in there. And then in the word, right, all right, now I think we're getting somewhere. So, so I need to, this is the wrong place. It's the next one. All right, right here. So that gets the index. And then this gets the value at the index. So then where do we have the, all right, so it looks like, let me try that. So let me run this. Okay. So now open up test.forward, do that, and then, yeah, so it's still stacking. Right? So, but did that work? Did it actually append that? Let's see. Let's see, format that print line. Let me come clean. I don't know Go. I mostly work with C++. That is fine. C++ is a lot harder than Go. So, yeah. I've used C++ just a small amount, and it is pretty complex. Pretty complex. Yeah. I don't know. I usually use C. Yeah, C is the language that I use mostly. And I've been using Go only, like I really only started using it a couple days ago, so I don't know that much. Yeah. It's quite a bit simpler than C++ though, so yeah. Print line with dot memory. Alright, so let's see, does that work? Yeah, let me get rid of that, and then we can see what it says. It doesn't print anything. Because we don't ever do that, so let's do that. There we go. Okay. So that's 0. Let's see, can we assign it here? Or will that fail? Okay. So what is the 1, 2, 3? Oh yeah, so that is in the pop. So we do get in there. And now, let's see. 1 is on the stack. So, okay. And then that's still stack underscore. Okay, so answer is not pushing still. Dot stack. Dot stack side. Dot stack sides. Okay. And then, alright, so there's no index of that. Wait, how do you index it again? What is the stack of this? No, I want to see. Right, it's up at the top, so I can look there. Right up here. Okay, so we have the stack that has stack size. Okay. Push and pop. Oh, so we need to do stack.stack to get the value of that. Okay. Did allocate stack. Well, Go automatically does all that for you. Yeah. It has like garbage collector or whatever, so you don't need to explicitly call like any allocator or anything like that. So that's not the issue. Because we also use the stack here. Like this pushes to the stack, and then we pop it off for this. So that is not what the issue is. Okay. But I was going to, yeah, so stack, not stack. And then with length 1. Yeah, so we need to do actually -1 there. Okay. And then we get 0. Okay. 0 pop. Let's do good.stack side. Okay. Stack size is 0. That's after we pop. So I thought a 0 initializes a structure. Well, yeah. 0 initializes, and then when we push to it, it will basically allocate that, on its own. Because we have a push function here. And it all works. Yeah. It's not like an allocation issue. It is the stack size. When you get here, the stack size is 1. I can show that here. Stack size is 1. But then, for some reason, it goes away. So that is right here. But then the stack size goes down. So that is where the issue is. Yeah, so it's still 1 after that. And then, but then on the next iteration, no, because there is no next iteration. But then, yeah, so if I do something here like that, and then do that, let's see. Now look in debugger. Yeah. I will do that in a second. But, yeah, so it's 0 here. So you can see it's not supposed to be that. Because this is the first one. Yeah, so it becomes 0 after that iteration for some reason. And that, what is this for? I don't know why that is. I didn't break anything though. So, yeah. So I will see that in a second. I'll look in the debugger. Okay. So. let me get rid of some of the logs because those make it a bit harder to see. Yeah. 1, 2, 3. So we do pop when we get there. Let me just do that though. We're not popping or anything. Okay. So it should set this up, and then it should be pushing this, which it does do. But then, actually, do I have an unmatched curly or something like that? Because that could be causing it, or something like, is it falling through? Like, I don't know why it would do that. Yeah, okay, well, I'll look at the debugger now. So, it won't have all that stuff, so it won't be calling to C functions and such. So, let me build it again. Alright, UDB main. Okay, and then I want to break on, let's see, I don't remember what it is. Let's see, whoops, I just closed that. And then this is good. Okay, so now, alright, let me close that. So let me try that again. Yeah, I need to look at main.c. Nope, it's main.go, because I'm using go. Okay, main.go, there we go. So what is the line number? Because it wasn't letting me use the label. So line number is 221. Okay. On 221. Okay. And then layout. No. To be enabled. And then run. Okay. Let's see what happens. So we're at main. So this should be the first one. So we get there and it should be assigning this. So let's see. Variable type. Yeah. So it is assigning this to that. So let me actually, let's display gorth.stack.stack size. Let's see. Also we want display gorth.stack.stack. Okay. It's capping. Okay, and then display, let's see. So we also want to look at gorth.memory, I suppose. Okay, so that is all good. So yeah, now the length of the memory is 1. That is as expected. And then here, it should push and the stack size should go up. So, I guess I didn't need the stack size because I can see the length right there. But, okay, so this is doing that. And then, we have the variable. Okay, so let me just go next and then print variable. So it's 0. So that is as expected. Now we're going to push here. And that should increase it. Ooh. Alright, so when we call the push, it does this. Okay, so that is where all this is happening. But at the end of this, it should increase the stack size. So, yeah. Okay, a lot of stuff in here, and now it's alright. Yeah, this is what goes on behind the scenes. Okay. Let's see. Just do. That doesn't work. And then it ended. Okay. So use S for step, and it should put you inside a subroutine. It just does that though. It just does the same thing as next. Not. We use not? I don't know what you mean. I don't know what is not. Oh, you mean, okay, you mean I need to start over, basically, right? That is what you meant. Okay, so let me try that. Break 221, and then run, and, yeah, okay, so let me try that. Let me do, to be enable, and then, step. Okay, so I'll do that, and then I'll step through this all. Okay, okay, now I am back in it, though. It still does that, so, yeah. Yeah, it still is in there. And then it ended the program. So, okay. Perhaps, actually. Let me break right after we call this. So, what is that? What is that one? So, that is here. Right after this. So basically on, let me put a new line here, and then, yeah, it won't be anything. So on 375 is where we'll break. So let me make it, 375, okay. And then, next I and step I in GDP. Alright, let me take a look at that. So, I'll open it up here. Okay. Step I. Step 1 instruction, but, oh, so I need to use step I, not just step. Or next I. It looks like this says next brings you into subroutine calls. Runs call but doesn't, yeah, so next I. Okay, run. And then, alright, so it just exited, so that didn't actually work. So I'll break on 221 again. And then re-enable. Run. Okay, so let me do next I. Step I. Next. Okay. So, okay, let's see. Whoops, hang on, wait, let me, not layout, display, stack. Stack. That is what I want to look at. Okay, so, stack.push. Okay, so in here, alright, right here. This is where, and then we go into here, so I don't want it to be in here. I don't understand. Yeah. Okay. That, I need to learn how to use that. I don't know why it does that, though. Okay. Let's see if I can just use print statements. Right here. So, the stack size increases here. I know that. But then it decreases. So it doesn't... Stack. Okay. But we don't actually pop, so... But, printing it on every iteration, so... Stack size. For some reason, it is 0. So, ooh, actually. Yeah, I know why. Actually, do I know why? Stack. Yeah, it's not stack size. Call print at the entry point of function and push and pop. Okay. Well, actually, I know it's working, though. It's just in this specific case. Like, if I do test.port, and I don't do any of this, I can just push 15 and 15 and then plus and print, and it works fine. Yeah, you can see 30, so it did work fine. This is just debug stuff. So that's not the issue. It's just specifically in that one, it doesn't push for this specific case. But it does push because I see it push. Yeah. So that's not what the issue is exactly. It's kind of like it's a weird issue. I don't know why. Yeah, but if I add another thing to it, yeah, you can see. So this, the stack size should be 1 here, but it's not. Okay, but in here, we can do gorth.stack.push, and it works fine. But then here, when we do it, we get to here, not here. It's actually right here. And it works fine. It increases the stack size, everything like that. I can print it, and I know that, but then it just, on the next iteration, it decrements. So I'm, so, yeah, I don't know why, but yeah, when I put like that there, it does iterate. Yeah, iterates through. See, 1, 2, and that. But then it just doesn't there. But it should be, because when we call that, we get here. I can print it out here. The value of it. But it just doesn't push, not what I wanted. Right. Yeah, it just doesn't do anything. So this is the value of the pointer. And then also gorth.stack.stack size. Maybe I could even do, yeah, see, it's 1 here. It's 1, but then it becomes 0 on the next iteration. Why do we only call this once though? So that might be an issue actually. Huh. Okay. That is actually interesting. So, oh shoot, that is not good. Oh man, I think I figured it out actually. Oh shoot. Actually, yeah. Okay. This is the issue. We're checking this, but if there's something after it, oh my gosh. If there's something after it, then it goes into here, but none of these become true. So we basically need to do the same thing again. Well actually, yeah, because we need to check it twice, basically. So I didn't mean to delete that, actually. We need to do it. There's probably a more concise way to do this, but now it'll work. Okay, now it works, and you can print out the index, and it works. Yeah, okay. That was the problem. That was the problem. That was the problem. Okay, let me get rid of the print here, and then there's also one in up here. Yeah, get rid of that, and there shouldn't be any more of that stuff. There still is one, so right here. And actually it's down here as well. So there we go. Yeah. Now we can print out. Okay. Now it works. Now let's try to set the value. So 12. Right there. And then we'll call answer. And then we will print the value out. So that is what that will do. Okay, so yeah. Invalid memory address. So yeah, I didn't actually update that to work with the indexes. So I need to do that. So instead of doing this, we want to push yeah, let's see. So we want to push what is it? So it is the memory of that address. So gorth dot memory at A. Something like that, I think. And also we need to change that here as well. I think that is correct. Gorth dot memory at A, just like that. And now unsafe imported not used, so I can get rid of that because we don't use that anymore. That was just for the RAM stuff. Okay, so there we go. I think it works now. I think it is actually working. So we should be able to, yeah, we have 25, and then we should be able to print it as many times as we want. 25, 25, perfect. That is superb. So after all that, I think it's finally working. I can make sure at works as well. Just like that. There we go. Okay. Yes. Okay, that is good. So now we are entirely using that. So, okay, I can't believe I got stuck on that. It was like an hour. I got stuck on that, and it was literally that one thing. Okay, just, all right. Let me clear this, actually. I will commit that now. Let's see. So, change from using physical memory addresses to using an index in simulated memory array. That is essentially what we did. Yeah, that's what I've been working on for the last however long it's been. So, yeah, let's actually make sure that worked. Yeah, it's been over an hour since I committed. So, okay. Now what do we need to work on? So what was, yeah, so now we were doing allocate. That is what I was working on. So we actually have all the lexing for that. But now that is why I want to do it, because then we can just increase the size of, let's see, of the memory. So basically, just we can zero allocate it. Yes. Oh wow. Okay. I'm sorry, I can't pronounce that name. Imoloism. Yeah, just rated. Thank you. I appreciate that. Let me actually do a shout out for you because that is very cool. Hello there, everyone. Everyone, we are working on building a fourth interpreter in Go. How are you all doing? Yes. Let me actually follow you. I have not heard of you before. So I just followed you. That is very cool. Hello, everyone. Yes. So yeah, we're building a fourth interpreter. We just finished. Nice truck there too. Yeah. So we just finished changing everything from using physical memory addresses to just indexes in the array. Let's see. So 2 new follows from the raiders. Thank you. I appreciate that. Okay. Now we are working on allocating memory. So that is what we're trying to do. We can do that. Yeah. Okay. So cells. Okay. As in array in the traditional sense. Yes. Okay. So no, the array is not constant. It is just it just dynamically adjusts based on however much stuff we put in it, essentially. Yeah, so, and then also, yeah, and it is a regular array. So it's basically just an array of integers, which correspond to values. And then we have another one for the variables, which the variables essentially store an index to the memory array. So that is how we use them. So I can sort of show that in here. If we declare a variable, we just call it test, that will create a new one a new variable in the hash map, sort of like a pointer. That is essentially what it is mimicking. So we create that, and then we can look at what this will actually output. It is, I didn't actually print it. There we go. It outputs 0. So that is the index of the array. And if we actually make another one, test2, so test2, and then print that, and it'll be 1, because it's the next index. So that's basically how that works, and then we can get the value stored at it if we use @, and you can also print that out. Yeah, so the value stored at it, we don't actually have any value stored at it, I forgot about that. So yeah, we can just put whatever value we want, 59, and then we can actually store that in test2, just like that. And now the value stored at it would be 59, as you can see here. So that is sort of how it works. Yeah. Before, I was doing it using actual pointers, like in the memory, but that's a bit complicated working with it like that, and it's easier to just simulate it when we're using a garbage collected language like Go. If I was using C, it'd probably be a bit easier just working with the regular memory, but this way I'm simulating it, and that way it's easier to adjust it. So that is basically what we are doing right now. So, yeah, it makes sense. Okay, good. I'm glad it makes sense. So, let me see. So now, yeah, now we are adding stuff for allocating memory. Okay. Is for type inference in Go, right? Yeah, so that's basically how you declare a variable, and it will just infer the type based on what you're doing. You can also declare it like this, and then you just put the type after if you want to. But yeah, so that is how that all works. Okay, so case. So this cells type. Okay. Okay. So basically, what that is supposed to do is it will basically push onto the stack this times the cells amount, which is just 1 in this version of the Go interpreter. So basically, depending on the system, I suppose is how it would change. But it's just kind of like semantics. Even though it's just the same as putting 5. So that's what we have to do here, basically. So I'm assuming it's something like size of char or something like that. Yeah. So it just depends on the system, really. But for this, we're just going to use 1. So basically, we're just going to pop off the stack. And then let's see. Then we can then we want to multiply that by the amount. So we can do gorth.stack.push a times yeah, so this can be a constant, I think. Cells size, essentially. So I will just actually let me do, and then something like that, cell size, and then I can declare that up here. So not in our node, but so cells size, and that can be equal to 1. So that is what it is right now. So let me run this. And okay, we don't actually use it. So let me do. So that's an enum. Yeah, that is how enumerators are in Go. It's not like I've seen some some people who like it and some people who don't like it. Yeah, but basically it's how you just define iota, and then this will basically iterate through it. Just like in C, it corresponds to like an integer. Yeah, but it's not like an actual type that you define here. So it is interesting. Yeah. Alright, so cell size. So if I do this and then cells and then print, it should still be 5 on top of the stack. But I can change cell size to be 2. Whoops, 2, and it would be 10. Alright, yeah, so I want it to be 1. I wonder if there is size of in Go. I'm not sure. But I'm assuming that's what it corresponds to. This doesn't say on this website that I'm using, so I don't know. I'll just set it to 1 for now, and I will adjust that later. So, now we need to do a lot. So, let me see. So what this basically allocates memory onto the memory array, essentially, based on however much the value is preceding it. So we can pop. We do need to do that. It is this. Stack.pop. The notation in the importance to remind me of the use of tuples in Rust, i.e. returning that effectively as void and foobar equals foobar. Okay. Imports. Oh, okay, that's what you meant. Alright. I'm not very familiar with Rust, so I don't know exactly what you are describing. But I think I get the idea of it. Yeah. Go is often compared to Rust as well. Yeah. Even though they're not very similar necessarily, Go is a lot simpler, I think. Okay, well this is what we're trying to do. So a lot. So I'm looking it up here as well. So we'll pop off the stack, and then we will basically just, let's see, to the memory, we want to just basically increase it by that amount. So, let's see. So we just want to append 0 for the amount of that, essentially. So it'll be 0 initialized. Worth.memory 0. Okay, so then we can do for I is 0. I is less than a. We'll do that, and then we will do this. So that will 0 initialize the memory, I think. That should work. Alright, so if I run that, we get that. And then, we can just get any index in the memory. So if I call a lot, that should work. Or actually, it's alloc. Is it a lot or alloc? It's a lot, actually, so yeah. Alright, so if I run that, it doesn't give me an error, and then I can print it out, and there shouldn't be anything. So yeah, stack underflow. But if I do like 3, and then I get the value at that and print it just like that, that should print 0. Okay, but if I get a value that's out of the range, like 6, then we get an error. So it did actually work. It 0 initialized the memory. But then we want numbers. Let's see. So yeah, numbers then points to the beginning of it. So you declare it right before, and that will be, so if I do variable numbers like that, then numbers points to 0 in the array. So I'm guessing test.forth is part of the actual code as you are recompiling when changing it right. Yeah, well, so I was actually, for debug purposes, I changed it to this, but before I was getting arguments. So I can actually change it back, because I don't need it like that right now. Yeah, and then I can just do this and do test.forth, and then you can provide it. So yeah, doesn't really matter. Yeah, so that'll declare it, and it will point to the beginning of the memory. Yeah, or wherever you declare it. So then now we have the beginning of the memory, and then if you do numbers, and then you do 2 plus, then that will point to after. So that's basically indexing the array is what we are doing here. So this 10 numbers, so the 10, okay, I don't remember exactly what this does, but 10 numbers 2 plus. So yeah, so actually you use cells. You don't have to, no, technically, but yeah. And then that sets the value. Yeah, I think that all should work actually. So I didn't actually provide it. That's not for. Okay, and then so that should set it equal to 10. Is what it's actually doing there. So it's setting the indexing the array essentially. This is how you index an array. And then you can set it to 20, the first one. And then if we do numbers 1 plus, so that will get the index of the array, and then we actually print it out, then it is 0. So it didn't work. So did I actually do something wrong here? I think I messed something up. So let me actually just print what that is. So 0. So it shouldn't be, or it should be 0. And then that will be 1, right? But it should be set to 20. So I think I messed something up somewhere. Did I do this wrong? Alright, let's do numbers at, so that's the first index. And print it out. And we get 0. It should be 10 though, because like in here, print it out, and it is 10. So yeah, I did mess something up. Either with the a lot or with this. So, yeah, I know what the problem is actually. So we don't handle that. I need to do that. Basically, I was only handling it if it follows a word, but we need to handle it otherwise as well. So that should be pretty easy. Basically, the this one, the bang. Right, yeah. So case, bang, right? So we can basically implement this the same. So there was some reason why I put it in here that I don't necessarily remember. And I didn't have it separate, like the out to at type. But yeah, so the pointer doesn't actually exist here. So we do need to get the pointer. Actually, it might not. Yeah, okay. So the reason is because of this. But if we just get the pointer from the top of the stack, then that should be fine. Yeah. So then this is basically, okay. I think that makes sense. Yeah, so Gorth.stack.pop. So the pointer actually is above it. Yeah, and then that should work. And then 10, okay. So can I just get rid of this entirely? Get rid of this check. Because I kind of want both of those. Let me try that. So I need to do this and then get the pointer, and then this actually iterates it rather than not iterate. So let me do that. Yeah, actually now that we're using indices rather than physical memory addresses, this actually will work. I think that was the reason why. So I think I can get rid of this entirely. And then just do that. And this actually is going to simplify itself. For now, I'll just make sure it works. And it doesn't work. Constant 34 of type int. Duplicate case. Oh, yeah, because this needs to be... This is... let's see. What is the bang type? Bang... Plus bang. That's what it's called. Yeah. So, if I run that... variable declared and not used. So, which one is declared? Is it... Oh, it's this one. So, variable. So, we don't need that then. Okay. Undefined variable. So we do need that. What is the issue here? It's actually because I use variable down here, is it? Yeah. I think that is the issue. So down here, yeah, I use variable. So variable is actually now pointed, right? No. So what is the variable? Wait, what was that? Let me put it back. So is Gorth.memory pointer. Oh, yeah. So basically we just need the current index plus a. That is what we want to do. So I think we can actually do plus equals a, like that. That should work, actually. So now I can get rid of that. And, alright, so 10. So now it's all seems to be working. And I can get rid of this as well, because that kind of, it's pointless. Alright, now, yeah, now we can index the array. So, now if I do 1 cells plus, like that, then we'll get the next index, 20. Alright, perfect. So now arrays. Not really arrays, but it is low-level arrays, essentially. So I do that. Let me see. Alright, and then this can be the third index and the second index. Okay, so now, yeah, this should still be 20. Then this should be 30. And this, 40. Alright, perfect. So that is actually working now. So, yeah, now we can allocate memory. And then actually use it. Alright, that is pretty cool. That is pretty cool. Yeah. So this also, yeah, you can make a function for that. I think I can do that as well. What is the offset minus address? I don't know what that means exactly. So let me try variable numbers. Let me try this out, and I don't know that I have full support for this. Okay. I don't even know what I have in my own interpreter. Okay. Actually, we need a space there. I don't think we have any quotation marks, or any parentheses, so I don't know that that will work. Okay. And then call 10, 0, number, that. And then, okay, so we didn't get an error. And then let's try to print it. Can't help but notice, but you speak super monotone. Yes, I do apologize for that. I don't know why. That's just how I talk. Yeah. Is it too quiet? Am I speaking too quiet though? That did actually work. It looks like. Yeah. Okay, this actually does work. That is pretty cool. Two. I actually like it. That is good. Okay. You have my focus. That is good. Alright, so that actually does work. So I don't know what this is doing. Because I don't have any lexing of parentheses like that. Yeah, so I don't know why this works. Yeah. Okay. Yes, but it does work. So, yeah. Alright, well that works. So, do I need this at all? Is it using this for anything? Because I don't know why it did. No. So it just works like that. Okay. That is good, I guess. So I don't know if that is just, yeah, I don't know. I have no idea. Numbers. Yeah, so that isn't, oh yeah, I didn't actually define them. Numbers, and then 3 cells a lot, and there we go, and then do that. Okay, and call number, and it doesn't, just number. Hang on, actually, so, yeah, I'm not sure. What is the, how is it okay? Yeah, 10, 0, number. Okay, well, it works, so. Alright, well, let's look at this. So, keyword input, yeah. So does the interpreter have an AST? It does not. Literally, all I do is lex it, and then immediately go to interpreting it. So I can actually show that. Yes. So basically, we lex it in here. It's just a long switch statement essentially. And then if it's not any of these, we check if it's a digit, and then we set it to push a digit. Otherwise, yeah, we just set it to a word. And then, yes, we just do that, and we have a list of them, and then we just immediately go into interpreting. So there's no parsing of any extent. So it does make it like I haven't implemented errors, or any kind of error handling really at all. But I don't think like with a language like this, you don't really need that. Unless it like with how it's set up, you can do error handling pretty fine just in the like runtime errors essentially. Like in the interpreter, you can catch things, and you can have the line number of each token. So it does work fine. Yeah, that is, yeah. So there's no parsing to any extent. Yeah. Okay. So key. Okay, that's the key number. All right, so we can do that pretty easily, I think. So basically we can just use scanf, I believe. Or hang on, let me look at Go keyboard input. That is what I want. So basically when we type key, it will just wait. Okay. Alright, so we can make a scanner. System. Alright, we want to get the individual key presses. So, like, yeah. ASCII code from a key press. Yeah, this is okay, so this I don't want to use one of those. Read single characters. That's not exact. I want to get key pressed. I spelled input wrong. Okay, so get key pressed. Key pressed. Let's see. Alright, so keyboard input. Read a character from without pressing enter. Let's see. So yeah, so that's not what I want. Like for a game, like when you make a game, you usually get it the same way. Could use that. Okay. Yeah, I don't want to get the byte. I want to get the that. Alright, that's a library. Maybe we could look at that. Because that looks like it's pretty much what I want. At least for Windows. Oh, it only works on Windows? Okay, let's see. Can we look at keyboard.go? Perhaps it would be in there. Let's see. So this uses, alright, quite a few things. Yeah. There's no standard library way to do this. There is, okay. Keyboard watcher. Yeah, I want to use the standard library. So, yeah, maybe I'll just, okay. I don't want to use one of those libraries like that. This one has time. Okay, go counter. Scan line. Okay, what does that do? Wait, so why a keyboard lock? Well, like, I want to get, yeah, the same way that this works, where you put in a key, and then you can type anyone. Not like, yeah, so we can virus people. Yeah, that's exactly why, actually. I want to send a virus. Send a virus over the internet to hack Facebook. Yeah, what is scan line? So that could be it. Scan line, go. Let me see. Is that what I want? That reads a string. That's not what I want. I just want a single keystroke. Huh. Okay. Let's see. Go keyline. Let's just look at that. Go keyline. Let's see. Not a package though. Let's see. Get keystroke. Okay. Yeah, not a library though. Okay. So not like an easy way to do this. Okay. Let me just try this scanner thing. That's buff.io. I think that is a standard library thing. Alright. So then, let me get rid of all this, and then just key. Oops, key. Yeah. And then just try to get that. So let me key type. Key type. There we go. And then we can lex that as well. It's key. And then token.category equals key type. Alright. And then, let's see. So then all the way at the bottom, case of key type. Alright, so then we will do this stuff and I'll see what happens. So scanner is bio.new scanner os.standardin. Alright, let's see. I don't think this is exactly what I want, but I might be able to use it like that. Let me just print line scanner.text. Let's see. So that is just going to get the whole thing that is typed, right? Alright, yeah, so that does that. But it doesn't end. How do you stop it? This is equivalent to print line. Let me see. What is that print line L? Yeah, I don't use Rust. Oh, it's exclamation point. Okay. Yeah, it's hard to tell in there. Yeah, sort of. A macro. Yeah, I don't know Rust. So, alright, so why does this actually, why does it go forever? How do you stop it? Can I just, how do you stop a scan? Go, end scan. Maybe I need to put buff.io. How do I end that? Okay. I just want to end it after one iteration. Rust is cool. It's kind of tough to learn though. Yeah. I've heard that it's rather similar to like C, like a combination of C, C++, and some sort of functional program like Haskell or OCaml or something. Like all of those in one. Yes, I have heard that. And that does sound rather difficult. Haskell. Okay. It has monads, but it's nice to work with. You mean Haskell or Go? Not Go, I mean, or Rust. Because I know Haskell does. Yeah. Rust. Oh, okay. Yeah, I plan to use Rust rather soon. Yes, or learn it at least. Try to learn it. Yeah. And I would like to, basically what I'm working on right here, I would like to also do it in Rust. And then sort of compare it to Go. Yeah. this as well as something else. So 2 projects. Yes, that is the plan. The coolest thing, I thought Rust didn't have monads yet. The coolest thing is air handling as it's in Eno. Rust Learning Stream when? That will be soon. So I want to finish this, and then there's another thing that I was working on. It's actually my Twitch bot. I want to do that. Okay, I want to finish that in Go, and then I'm going to implement both of those in Rust. That is the plan. So rather soon. Stay tuned. Yeah. So let's see, scanner, because I'm almost done with this. Like, basically, I'm just implementing what's on this page. It might not be all of 4th, but yeah, it is a good amount of it. That is the plan, and this is actually the last thing it looks like, except what is in here, and I don't know what it all is in there. So yeah. Okay, so I'm almost done with this actually. All right, and then I'm just gonna clean this up and stuff, obviously. Oh shoot, I've been streaming for 3 hours. I actually have to go soon, so I'm gonna try to finish this. Okay. Man, I've just been having a lot of fun. So let me do this. So that is s.scan. Okay, I apologize because I don't know how to pronounce your name. It's probably something really easy, but it's hard with the no capitalization. But you just followed. Thank you. I appreciate that. Okay, so this isn't what I want. Let me put buff IO. IO. Buff IO. I want to end the scanner. Buff IO scan. That is what I want to end. Okay, let's see. Let's see. Okay. New scanner. Yep, standard in. Alright, let me see. Cerno. Okay, so that is how you pronounce that. Cerno. That is what I will call you. What am I looking? Alright, scanner.scan. Let me try that rather than this. Actually, hang on. So what is that? So scanner.scan. Actually, hang on. Wait. So this is, yeah. So while that is true, and then let me just do scanner equals false. Can I do that? So we can just get one thing. Shoot. There we go. Can I use false? Scanner.scan. No. Can I use break? Okay. Alright, so that works. But I just want to get one. So how can I make it? I can only get one thing, one keystroke, because enter, that can be detected. Yeah, but I can't really get all of them, like control and stuff. This isn't exactly what I want. Reader. What window manager to use? It is Awesome Window Manager. Here, I can actually provide a link to it. Awesome Window Manager. Yes, I would like to switch to DWM at some point. I mean, Awesome is great. It's awesome, but, I've been using DWM, like, on my laptop, and it is quite nice. Oh, you do know what it is. Okay, very cool. Yeah, I haven't configured it very much, because, like, out of the box, mostly worked for me. Just a few things I changed. Yeah, so, for scanner, not scan. What else does scanner have, actually? What else does the... Can I just print the whole thing? Will that work? Ooh, okay. So, that maybe is not what I want. Maybe. Stock DRM is fine, but there is a flexi patch if you really need something and can't manually patch it. Well, yeah, well, that is kind of... Oh, the config is lame. Well, I don't know. I haven't done much to the config, because I just installed it a few days ago on my laptop, but, I don't know. I kind of like configuring it in C. I do like that idea. Okay, so that doesn't do anything. I want to just get the keystroke pressed. And that... Go get keystroke. I just want that. Okay. Watcher. That is a library, though. There's nothing. None that isn't a package. Alright, I don't know that I want to do that right now. Because I just want to only depend on the standard library. Golang keyboard capture. Look at the source code of that library. Yeah. well, yeah. Just, some of them were kind of big. Let me look at this one specifically. Is it, let's see, do we have source files? .go, keys, let's see. Yeah, like there's a bunch of, quite a few files actually. Ooh, okay, so this is all the different keys. So this is just like a numerator, it looks like. Yeah. Okay. I mean, I could just copy and paste that. But then the actual, let's see, events. Okay. Glad it's not just me that does that. That does what specifically? When docs are bad, I just look at the source code. Yes. Well, really, I'm just trying to figure out how it works because I don't want to use it because it's not a standard library package. So, but I think, user input string, and then, all right, so it's actually pretty simple. It looks like the watcher. Let's look at that. So this is okay. So this is where the more complicated stuff is. So this actually changes the state. Okay. Yeah, this might be a bit more complicated than I wanted it to be. Calling up with too many external packages too. Yeah. Yeah, I might have to just kind of implement a similar thing myself. But I don't want to do that right now. This is C. Wait, you can just import C from Go, right? I'm quite certain you can. Could I just write this in C? Perhaps. I still don't know that I want to do that right now. So, type T, extern C. Maybe I'll just write the whole thing in C, rewrite it all, and then just import it to Go and just have that as like the wrapper. Yeah. Okay. So, okay. So let me actually look at this. Type T in. That might be something. Start. Let's see. Yeah. Okay, yeah, I'm gonna have to go, so I'm going to have to look into this and then figure out what I can do off stream, and then I will implement it next stream. Yeah, I don't actually want to write it all in C. That was kind of a joke. But yeah, so I'll try to write it all in Go. So I am going to end the stream shortly. Let me look at what else is in here though, because there is some certain things I think in here that weren't defined before. All of this looks fine though. If you don't care about being used in Windows, you could just read that. Well, I kind of want it to be cross-platform too, but I might just do that if I can't figure out something better. Yeah. Two disclaimers. Okay. So non-standard editions. Yeah, so that actually uses that. So I'm not going to implement this, because I use it. If you ever consider writing an IRC bot, that'd be a great watch. That is a plan. So I have right now, I can show this. I have my Twitch bot. Hang on, I can exit out here. Twitch bot. And I have it here, but I'm using this external library. And I want to implement that myself. So that is actually the plan. Discord. I don't actually have a Discord. I apologize. I should make one though. Yeah. So basically, yeah, this is what I have. I'm using this, and I don't want to be using that. I just did that because I wanted something pretty quickly, but that is the plan. So after I finish this fourth interpreter, that is the plan. I'm going to write that, so IRC client, and then actually use that for my bot rather than what I'm using now. Yes. That is the goal. So, that's your IRC library. All right. Hang on. Cool. There we go. Let me look at this. Okay, working on my own client for fun. All right. Oh, this is Rust. All right. Cool stuff. All right. All right. Yeah, I don't understand any of this. Rust, kind of weird to look at if you aren't familiar with it. Yeah. But this is a very cool thing. Once I learn Rust, I will give this a read. Asynchronous too. Okay. Yeah, that is very cool. Weak to write. Oh, nice. Is it all finished then? Let's see. Let me look at Event handler, let's see. Okay. Enums. Yeah, I haven't ever seen a Rust enum. I don't think I've ever read that. Git clone it. Alright, let's see. Okay. I already have those. Okay, I already have that. Alright, and that doesn't work, so how do you do that? You need to edit the config file. Okay. Let's see, how do I... Oh, up to that. Okay, yeah, so I was too far. So let's see. Right here. Alright, there we go. Yeah. There we go. Alright, so let me go into there. So let me see if I can figure this out. So, cargo run. So it's gonna fail. Alright, hopefully it doesn't take too long. Edit the config to we'll do one server for now. Alright, I'll just cancel that. So cargo exit. Core.top. Interpreter exit at that or quit. No, I want it to scan the input essentially. Like basically just one key stroke. Yeah, cargo.com. Okay. Just one keystroke. So, right, what am I doing in here? To do one server. Config session. Okay. Config. Oh. Config.com. Okay. Okay. Yeah, I want it to, sorry, let me just finish that. So I want it to just read one keystroke. Like if you're playing a game, like if you press spacebar, control, whatever, I want it to read that essentially. Is what I'm trying to do without any external libraries. Okay, so I just want to get rid of these ones. Is that what you mean? Just like that, basically. Yeah. All right. So the proof of concept for the library, it just reads from the standard. Okay, so let me do cargo run. All right, I do really have to go quite soon, so hopefully it doesn't take too long. All right. Give it a Nick and Stu. Oh, okay. I need to do that. Okay. Config.com. Nickname. Nickname. Nick. Username. User. Okay. Real name. I'll just leave it at that. Okay, so let me try that. Cargo run. Let's see. Let's see what happens. All right. After this, I will have to go. So let's see if I can figure this out. Nick will probably take it. All right. Well, I can change it if it doesn't work. But this is gonna have to update. I haven't used like I used Rust. It was like a year and a half ago or something. So I haven't updated anything since then or whatever. So I don't know if it's all gonna work. Yeah. So this may take a minute. Very engaging content. My internet gets really slow while I'm trying to stream, so yeah, it's a little slow. Okay, I can read about, I'll leave that open, just like that. Okay, so yes. Don't use Archstream, update with your packages. Partial upgrades are on Arch. Yeah, no, it updates that, but, it doesn't actually update the, yeah, it doesn't update, like, if you run cargo update or whatever it is, it doesn't do that. But it updates cargo itself. Yeah, and also Neutrino, I think if I pronounced that right, just followed, thank you. Unless using Rust up. I don't know. I don't remember anything I'm doing with Rust. But it does update, like, Rust itself or whatever. Yeah. Okay, 20%, let's go. Pattern times were never that bad for me. Rust up. Alright, it's a neat trick. Yeah, okay. I use Portage to manage to my system Rust installation. Gentoo provides a way to port it. So you use Gentoo. Gentoo. I've never used Gentoo. Really fast to run. Okay. Trying to keep up with chat. Okay, let's see. Keyboard. What does this do? This is a package though. It's not what I want. Not package. Yeah. Okay, yep. 25%. Let's go. Almost there. Um, um, yeah, I'm gonna have to look at this. We're streaming Gen 2 stuff, and that's where we came from. Oh, okay. Well, I'm not familiar with their content, so yes, I will start watching them now. But that is very cool, Gen 2 stuff. Key go get. Speeding up. Oh, let's go. Yes, I do apologize for being so. Maybe if I don't think that's really would really do anything, but all right. Let's see if it'll go. Engaging content. Yeah, I don't know what to do while we're waiting. So maybe. Cool. Let's see. Do you live in the Sahara or something? Why is it's no, it's not usually this bad. It is because I am streaming actually. That is why. It just completely kills it. Oh shoot. Link to my make.com to check out that. Hang on. Let me actually there, I paused the stream because I have it open on the side, so maybe it'll go a little faster. If it's not trying to download it as well. Let's see. Alright, make.com. Oh my gosh. Okay, 100 kilobytes a second. Yeah, now I think it's completely dead. Can't even load this. Yeah, that is nice. Okay. Holy moly. Okay, yeah. I think my internet is completely dead now. I don't even know if this stream, looks like it's still going. Yeah, I might need to actually go and check this out next stream. Yeah, just let it go, because I really have to go, in a moment. Okay. Peace PC, well, let me see that. Okay. So, Threadripper? 256 gigabytes of RAM. Wow. Dual Xeon. I've got, let's see, 12 gigabytes of RAM. So, pretty close. That's a lot of RAM. Yeah, 32 cores. I've got 4 cores. Let's see, how is that going? Yeah, it's not gonna make it. It's not gonna make it. Okay. Okay. Yes, I do have to go. So, thank you for watching. Yes, and I will see you guys later. So next stream, I will take a look at that. If you are there, I'll go through it all. If you guys are there. LLVM, my system toolchain. Alright, yeah.